In triangle ABC, it is an isosceles triangle with AB equal to AC equal to 10. All right? And BC is 12. The points S and R are on BC such that BS to SR to RC is 1, 2, 1. Okay? The midpoints of AB and AC are P and Q respectively. Perpendiculars are drawn from P and R to SQ, meeting at M and N respectively, the length of MN. All right. All right, so let's draw this out a little bit bigger. So first, let's start labeling this. Well, AC is 10, and AB is also 10, and BC is 12. And then these sides here, they've given us the ratio. It's 1 to 2 to 1. So if this is x, and this is 2x, correct? And then the total is 12, so that means 4x is equal to 12, and therefore x is equal to 3. So this is 3, and this is 6. Okay? The midpoints of AB and AC are P and Q. So P and Q are midpoints, so therefore from here to here is 5, and from here to here is 5, and similarly from here to here is 5, and from there to there is 5. And I think in terms of labeling, that's all we have so far. And I now need to start drawing in some relationships. So I'm just going to draw this perpendicular here from P to S, like that. And then I'll draw one right across from P to Q. And I think that should be it. I think that's all we need to solve this question. All right? So far, I hope you're following me. You can do this, even though it's number 25. Just follow me. I promise you, you will understand it. So far, no problems, right? Okay. So here we go. This next step is I want you to look at triangle PSQ. This one right here. PSQ. This triangle. That triangle is a right triangle, correct? So I drew it over there just so I wouldn't make this diagram messy. So this is P, this is S, and this is Q. And here's a right triangle. Now SQ, we can create a Pythagorean relationship, correct? Now how do we do that? Well, I hope you figured out the length of PS. Well, what is it? Well, from here to here is 3, and from here to here is 5. And then therefore, this is a 3, 4, 5 triangle, right? And you can prove that with Pythagoras, pretty simple, but 3, 4, 5 triangles are a very common Pythagorean relationship. So that means PS is 4. PQ is also known. PQ from here to here is also known because it's the same as SR. I think if I drew another perpendicular from Q down to R, it would probably be a little bit more believable that PQ is the same as SR. That PQ is the same as SR. All right? So if SR is 6, PQ is 6. So now using Pythagoras, we can solve for SQ squared, or SQ rather. That's 4 squared plus 6 squared, which looks like 16 plus 36. So therefore, SQ is equal to the root of 52. Okay? So that takes care of that. Let's move this up a bit, because we're going to need a little bit more space here. All right. So now, where do we go from here? Now I want you to concentrate on the following triangles. The first one is this one right here. I'll draw it in red. SMP, that one right there. This one, SMP, all right? And that triangle we have SM squared plus PM squared is equal to 4 squared. Correct? I want you to be convinced of that. So that means PM squared is equal to 16 minus SM squared. Okay? Strictly from Pythagoras, no tricks. Then I want you to look at the following triangle, PMQ. PMQ, this one right here. In that triangle, we have PM squared plus MQ squared is equal to PQ squared. And PM squared, therefore, plus MQ squared, PQ we know is 6, so it becomes 36. And therefore solving for PM squared is 36 minus MQ squared, like that. All right? So now we have PM is equal to 16 minus SM squared, and we have PM squared is equal to 36 minus MQ squared. And therefore we can set them equal to each other. So that means 16 minus SM squared is equal to 36 minus MQ squared. Like that. Now, before I continue with this equation, we have to get this in terms of one variable, but look at the relationship between SM and MQ. Here's SM, here's MQ. What is the relationship? Well, SM plus MQ is equal to SQ, correct? And SQ, we figured out up there was root 52. So that means we can say that MQ is equal to root 52 minus SM. And we can use that to substitute into here. So let's do that. We've got 16 minus SM squared equals 36 minus root 52 minus SM, like that, all squared. All right, and then instead of having to write out SM every time, I'm just going to let it equal whatever variable you want, y. It just makes it simpler. So now I've got 16 minus y squared is equal to 36 minus root 52 minus y, all squared. All right, so we have to now solve for this. 16 minus y squared is equal to 36 minus 52 minus 2 root 52 plus y squared. 16 minus y squared is equal to 36 minus 52 plus 2 root 52 minus y squared. The y squareds disappear because they're the same on both sides. This should be a y, sorry. Right there. Don't make that mistake. All right, so what do we got? 36 minus 52 and plus 2 root 52y. Okay, so we're getting pretty close to solving this. Put everything on one side. 16 minus 36 plus 52. And this looks like minus 20 plus 52, which is going to be plus 32, 2 root 52y, and therefore y is equal to 16 over root 52, like that. There you go. Now, what were they asking for in this question? They're asking for the length of MN. All right? Shouldn't be too bad to figure out MN. MN is what? MN is from here to here. This guy right there. So MN is essentially SQ minus 2SM. Why? Because SM is the same as NQ because of the symmetry of that diagram. Okay? So let's figure out MN. So therefore, finally, MN is equal to SQ minus 2SM. SQ we figured out way at the very beginning is root 52. And 2 minus SM, well, SM was y, and y is equal to 16 over root 52, like that. All right? So we just have to figure this out right here. So let's see, top and bottom, root 52, trying to get a common denominator here. Minus 32 over root 52. So this looks like 52 minus 32 over root 52. And this is 20 over root 52. And I think the root 52 we can simplify a little bit more because that's 4 times 13, correct? Like that. So then therefore this becomes 20 over 2 root 13. And finally that's 10 over root 13. 10 over root 13. And therefore the answer is 25 is B. A palindrome is a positive integer whose digits are the same when read forwards or backwards. For example, 2882 is a 4-digit palindrome. 49194 is a 5-digit palindrome. There are pairs of 4-digit palindromes whose sum is a 5-digit palindrome. One such pair is 2889 and 9339. How many such pairs are there? Okay, so first let's understand this question before we proceed with it. They are saying that you have a pair of palindromes that are each 4-digit numbers, 2882 and 9339. So individually, each of these are 4-digit palindromes. And when you add them, which in this case is 12221, this also becomes a palindrome, but this time it's a 5-digit palindrome. Okay? And that is the explanation and the example. And this is one such pair. They want you to figure out how many such pairs are there. So pairs of 2 numbers where each of the numbers are palindromes and are 4 digits, when added, will result in a 5-digit number that is also a palindrome. Okay? So what we will do initially is use some letters to describe or represent each palindrome that's 4 digits. The first one I'll call A, B, B, A, and C, D, D, C. And when you add them up, they will give a 5-digit palindrome. So I will call it G, E, F, E, G, like that, okay? And we don't know what these letters are, but this is just a representation. Now let's try to figure out some clues here as to what this possibly could be in terms of numbers. The largest possible 4-digit number is 9999, correct? And interestingly, that's also a palindrome. So if you add 2 of them, very similar to what I did up there, you would get a sum of 19998. So this is the maximum sum of 2 4-digit numbers. So therefore, the maximum value for this first digit is a 1. You can never get anything greater than a 1. Can you get a 0? Well, you can, but if you put 0 there, it's not a 5-digit number anymore. We want a 5-digit number. A 5-digit number that's a palindrome. So that basically means that this G is a 1. That's the only way this can work. So that becomes a 1. Like that. And therefore this G is a 1. Okay? So that's the first part of our question. We're going to slowly try to systematically figure out all the possible numbers. Now, before we create an algebraic equation, we need to look at this column right here. Based on simple addition, A plus C, it should equal 1, correct? All right, possible. But if that's the case, then what about this guy right here? That A plus C would also equal 1. But if that's the case, then this guy doesn't need to be there. It would become a 4-digit number. So A plus C equal to 1 is probably not going to work. Okay? So then we say, well, then how is this going to work here if A plus C is not 1? Well, A plus C could equal 11. Right? Because if it equals 11, you put the 1 down there and you carry the 1. Based on simple addition. And that is the only way this is going to work. It must be that A plus C is equal to 11. All right? That's the only way you can produce a 5-digit number, which hopefully will then be a palindrome. Okay? So, that is the first part of the question, and now we proceed to the second part. The second part of the question basically involves we have to now use this and write it all out as if it was an actual number. Right now it's just letters, right? So the first part, ABBA, what is that really? It's 1,000 times A, the first digit, plus 100 times B, plus 10 times B, plus A. Correct? And you are adding to that number, which is very similarly 1,000 times C, plus 100 times D, plus 10 times D, plus C. And that equals this number, which is 10,000 plus 1,000 E, plus 100F, plus 10E, plus 1. Okay? So that is how this is all written out. And this guy is a 5-digit palindrome. Or it must be. That's what we are trying to figure out. Okay. Let's move forward with this here. I'll keep this. That should be good enough. All right. So here we go. Let's add all this as much as we can. The A's become 1001A. The B's, we got 110B. What else do we have here? We have the C's is 1001C plus 110D. And this whole thing is our 5-digit palindrome. Like that. We are concerned really with trying to figure out A, B, C, D, and E. Like that. So on the left side, the 1001, we can probably factor A plus C, and the 110 we can factor B plus D, like that. And the right side is our 5-digit palindrome. Okay? So hopefully so far you're not lost. Now, this is where the magic comes in. A plus C we have determined must be 11. So we can put that in there. 1001 is 11 plus 110 plus B plus D, like that. And therefore this becomes 11011 plus 110 B plus D is equal to a palindrome. And that's about as far as we can go there. So now at this point, we've got to figure out a table here. We've got 1, 1, 0, 1, 1, and we have b plus d. If we choose different values, what will be the result? The result has to be a 5-digit palindrome. Okay? So let's see what we get. And first of all, b plus d, b and d are digits, right? So the lowest possible sum is 0 and 0. So that's 0 plus 0, like that, which would be 0. And the highest possible sum, if both of them were 9s. So 9 plus 9, which is 18. And we have to figure out the value of this for each of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Great, fit them all in. All right, let's go with this now. So when it's 0, it just becomes 1, 1, 0, 1, 1. Is this result a 5-digit palindrome, which is what we want? And the answer is yes. So great, we got our first scenario here. B plus D is equal to 0. And if we keep going, the math in this is pretty straightforward. You're just adding 110 each time, so it shouldn't be that hard. So this is going to be 1, 1, 1, 2, 1, 1, 1, 3, 1, 1, 2, 3, 1, 1, 1, 3, 4, 1, and so on. So we got 1, 1, 4, 5, 1, and I'll fill them all in. So there you have it. Those are all the numbers. So how many of these result in a palindrome? Well, let's see. Let's look down the list. And it looks like the only one is this one here. All the others are not palindromes. So we get a palindrome when b plus d is equal to 0 and when b plus d is equal to 11. So great, we have b plus d, but we have to figure out also a and c, right? Those numbers, that pair, are not just b and d, they involve an a and a c. So now our next step is to figure out a and c, but we know that a plus c is equal to 11, so that should definitely help us out. So remember, we've got two scenarios, b plus d is equal to 0 and b plus d is equal to 11. So now we must figure out values of a and c. A and c will make a little table. We know that a plus c is equal to 11, right? So that is definitely going to help us. And we have only two scenarios for b plus d. We have b plus d equal to 0 and b plus d is equal to, if you remember, 11. These two scenarios right there. B plus D is equal to 11, like that. Okay, let's proceed with this table. So A plus C is equal to 11, right? So A, for example, can be 1 and C can be 10, correct? No, because they have to be digits. So that's wrong. A can be 2 and C can be 9, correct? Yes. Is A plus C is 11 in this case? Yep. And B plus D is equal to 0. All right. That's fine. So that's one possibility, right? And that I'll put the possibilities in brackets like that. I just don't want to get this too confusing. Now, before I continue, I want you to understand what just happened here. Right? You think, okay, you got all these letters. We've created two palindromes. Remember our palindromes were A, B, B, A, and C, D, D, C, right? All the way at the very beginning, right here. A, B, B, A, and C, D, D, C, correct? So we created two. And we created the ones as follows. For A, B, B, A, let's see, and B and D equals 0, so that means B is 0 and D is 0. That's the only way this will work, right? Because you can't have negative numbers. You can't have 4, -2, 6, 1. That's not a number. So what numbers did we create with A equal to 2, C equal to 9, B equal to 0, and D equal to 0? Well, let's see here. We got 2, 0, 0, 2, and 9, 0, 0, 9. These are indeed two 4-digit palindromes, correct? And if I add them, I hope that I get a 5-digit palindrome. And I do. I get this one. So this is what I created. A pair. A pair of two 4-digit palindromes whose sum is a 5-digit palindrome. Okay? Let's keep going here. So for A, we got 3, 8. This checks out. This would give me one more scenario. Okay, and you can write them all out. What else do we got? 4, 7, 5, 6, 6, 5, 7, 4, 8, 3, and 9, 2. For each of these of course will all check out, and for each of these it'll be exactly the same. B is 0, D is 0, and each of these will give us one scenario, one pair. It's better to call it a pair than a scenario. So how many do I have total? I've got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 pairs. Okay, so what are our answer choices, just out of curiosity here? How many do they say? Ooh, 28, 32, 36, 40, and 44. Okay, I got quite a few more. Oh boy. All right, no problem. But so far you're understanding, right? Now, the only other scenario, the good news is B plus D is equal to 11. Okay, that's it. But B plus D equals to 11, unfortunately, is not as simple as when B plus D equaled 0. In this case, we're going to have a little bit more to figure out. So if B plus D is equal to 11, we've got quite a few scenarios. We've got B and D, let's say, I'll put it here on the side. B and D. We have 2, 9, 3, 8. I hope this looks familiar. 4, 7, 5, 6, 6, 5, 7, 4, 8, 3, and 9, 2. So for each of these, for example, when A is 2 and C is 9, each of these is going to give 1, 2, 3, 4, 5, 6, 7, 8 possibilities for B plus D is equal to 11. See what I mean? You just have to take all of these and throw it into there. I hope that makes sense. And very similarly, for each pair of A and C, like that, you're going to have 8 possibilities. So this will give you 8 pairs, this will give you 8 pairs, this will give you 8, and so on, like that. So just to help you understand, if let's say you had A is 2 and C is 9 and B is 2 and D is 9, what would be our numbers? I'll draw it down here. A, B, B, A, and C, D, D, C. It would be 2, 2, 2, 2, and then C is 9, right? So 9, 9, and then what is D? 9. So this is our pair. 2 4-digit palindromes that have a sum which is a 5-digit palindrome. And similarly, you can do the same for B is 3, D is 8, B is 4, D is 7, like that. All right. So now, finally, let's total it all up. All of these. These are all the pairs. So we got 1, 2, 3, 4, 5, 6, 7, 8. 8 times 8 plus 1, 2, 3, 4, 5, 6, 7, 8. 8 times 1. And this looks like 8 plus 64, which is 72. All right, let's go back and see if 72 is one of the answers. And it is not. Oh. Well, that means we double counted then, because I saw 36 in there. Yeah, I saw 36 in there. Oh, okay. We double counted. All right, no problem. Now you might say, oh boy, what do you mean by that, double counted? Well, I'll explain. So for example, let's just choose one of these guys here. AC, choose this one here. A and C is 4 and 7, and B and D, you can choose, it doesn't really matter, 6, 5, all right? So A is 4, C is 7, B is 6, and D is 5, right? I'm just giving an example to illustrate why we double counted. If you chose these numbers, what would be our two palindromes, our two 4-digit palindromes? They would be 4664 and 7557, right? And the sum is 1, 2, 2, 2, 1, like that. Now, let's say we chose A is equal to 7 and C is equal to 4 and B is equal to 5 and D is equal to 6. What would be our palindromes for A, B, B, A, and C, D, D, C? Well, we'd have, let's see here, 7, 5, 5, 7 and 4, 6, 6, 4. And the sum would be 1, 2, 2, 1. But notice this pair is the same as this pair. It's the same pair. So we double counted. You see, I hope that makes sense. So therefore, this 72 is listing a set of pairs twice. So to get the number of unique pairs, you have to divide by 2. So I wrote it out. 72 is twice the number of unique pairs. Number of unique pairs is 72 divided by 2, which is 36. And therefore, the answer is 36, which is C. A student has 2 open-topped cylindrical containers. The walls of the 2 containers are thin enough so that their width can be ignored. The larger container has a height of 20 centimeters and a radius of 6 centimeters and contains water to a depth of 17 centimeters. The smaller container has a height of 18 centimeters, a radius of 5 centimeters, and is empty. The student slowly lowers the smaller container into the larger container as shown in the cross-section of the cylinders in Figure 1. As the smaller container is lowered, the water first overflows over the larger container, Figure 2, and then eventually pours into the smaller container. When the smaller container is resting on the bottom of the larger container, the depth of the water in the smaller container will be closest to. So, the first thing I want to do is figure out the volume of the water in the container before anything happens. Okay? Before any smaller container is lowered and all of that. So that's our first step. So how do we figure out the volume of a cylinder? Pi r squared times height. All right? So in our case, we have pi. What is the radius of this big guy? So because it's the big one, I'm going to use big R and big H. The radius of the larger container is 6 and the height is 20. But be careful, The radius is 6, that's fine. 6 squared. But in our example, the water doesn't go up all the way to 20. It only goes up to 17, and you can clearly see that in the diagram. So we have to use 17 for the height of the water. So therefore, this becomes pi times 36 times 17, which is equal to 612 pi. So this represents the initial amount of water. Now, step number 2 in this question is to figure out what happens when this small container right here that is empty is lowered into the bigger one. Now, notice initially nothing's happening. It only starts to overflow once the small container touches the water and pushes it to the top. Up until that point, nothing overflows. It only overflows once the water is all the way at the top. All right, very important to understand that. So second thing I'm going to do is figure out how much water is remaining once this container is lowered into the bigger one. So this represents the scenario of when the smaller container, which I have drawn in green, is lowered all the way into the big container, which I have drawn in black. And the blue bar at the top represents the level of the water. That water that is in there is what we need to figure out. That is how much is remaining, because all the rest of the water has flown right out. Okay? So how do we figure out the volume of the water that is remaining in this figure now? Well, we take pi big R squared times height, the whole cylinder, and then we subtract from it, obviously, the empty small cylinder, which is going to be pi small r squared small h, like that. Okay? And this is VR, volume remaining, volume of water remaining. So let's see. Pi, radius of the big cylinder was 6. They tell you that in the question. The height, the full height of the big cylinder is 20. And then pi small r, the container that is smaller has a radius of 5. And the height of the small container is 18. So this becomes pi times 36 times 20 minus pi times 25 times 18, which is 720 pi minus 450 pi. And this is 270 pi. So this is how much water is remaining. And now the next thing I'm going to figure out is how much flowed out. Well, that shouldn't be too hard. Initially, you had 612 pi of water, and 270 is remaining. So if x represents how much flowed out, x can be calculated pretty straightforward manner, in a straightforward manner. It's just 612 minus 270, and therefore x is 342. So this is the amount that flowed out. All right? Now, I want you to figure out the volume of the small cylinder, because that's pretty important. Volume of the small cylinder, pi small r squared times small height. If you remember, the radius was 5, the height was 18. So this is 450 pi. Now I want you to compare the volume of the small cylinder to the amount that flowed out. I forgot a pi there. Compare 342 pi to 450 pi. The amount that flowed out is less than the volume of the small cylinder. Why? If you put that small cylinder in, wouldn't the amount that flows out be equal to the small cylinder? Why is the amount less? And that is a very important part of this question that is crucial. The reason is because look what happens when you first put the small cylinder into the big one. Initially, the water level rises to here, right? But nothing is flowing out until you get the water all the way to the top. And the reason is because the water level initially was at 17. It was not at 20. If the water level was initially at 20, then yes, the amount that flows out would be equal to the volume of the cylinder. But the initial height of the water is not 20, it's 17. And that is a crucial part of this question that unfortunately can get you the wrong answer or get you an answer that's not even close to the answer choices. All right, so we are basically at our final step, step number 5. And I need to draw a diagram. All right, so before I get to the diagram, I just want to emphasize that point that the amount that flowed out, 342 pi, is less than the volume of the small cylinder, and I explained why. All right, now we get to the final step. So the final step is when the small cylinder that I've drawn in green is at the very bottom. It's sitting at the very bottom, and all the water is now settled. The amount that flowed out is gone, and the water level is now at the very top to match the height of the small cylinder, and a segment of the water has flowed into the small cylinder. All right, so now we have to figure out this value right here, right there, the amount of water, the height of the water inside the small cylinder. I'll remind you, look at the question again. The depth of the water in the small container, that is what they want. All right, so I've denoted that with this orange line, and I'll call it y. I'll give it an actual value. We'll call it y. All right, so now this is how we do this. Our remaining water is 270. That's how much water is remaining, okay? So 270 is a very important number for us. And how do we figure out that? Well, we have to figure out the area of this blue shaded region. So it's the whole cylinder. So pi r squared height minus the small cylinder, pi r squared height. But our height is not going to be 18, which is the height of the small cylinder. Our height is only going to be from here to here, because that's the part that's empty, and that's what we have to subtract. So from there to there, what is that? Well, we know the height of the total cylinder, the small one, is 18, right? And this is y. So this segment here has to be 18 minus y. Okay? Like that. So let's start plugging in our values. Pi r of the big cylinder was 6, so we got 6 squared. And the height, we are only interested in this height right here, and that is 18. Why? Because that's the height of the small cylinder. So be careful about the numbers that you're putting in. Pi r squared of the small cylinder, and that radius was 5. And then height, we're subtracting the empty part, so that is going to be 18 minus y. Like that. All right, so this is going to give us our value for y. The pi's cancel, so that just leaves you with 270, and we get 36 times 18, which is 648. And this will give you 25 times 18 and plus 25y, like that. So we got 270 is equal to 648 minus 450 plus 25y. And this becomes 648 minus 450, which is 198, 270 plus 25y. And then 198, put that over on the other side, and that's going to give you 72 is 25y. And then finally y is going to be 72 divided by 25, which is 2.88. And there you go. That is what they want you to figure out. The height of the water in the small cylinder when the cylinder is all the way at the bottom. So 2.88, let's see what we get. Number 25, 2.88 is choice D. In the cube shown, L and K are the midpoints of adjacent edges AD and AB. The perpendicular distance from F to the line segment LK is 10. What is the volume of the cube to the nearest integer? So first thing I'd like to do is draw some lines to illustrate what is going on. The first thing, of course, is we want to draw a line from LK to F, because that is what they tell us is 10. So here is F all the way till LK. And the perpendicular distance, that's the important part. So there you go, and perpendicular distance, so that means that this is a right angle, right there. And then now I will draw in a few more lines that I will need to use later in the question to figure out all the lengths and then therefore eventually the volume of the cube. So the next line is from L down to F. Now I will draw a line from L down to the bottom like that. And since L is the midpoint of AD, this will basically be the midpoint of that segment. So this is, let's say, E. And finally, one final line should suffice, and that is from F to E, like this. And there you go. These lines will help us solve this question. So let's begin. The first thing, of course, now that this diagram has been drawn, I need to give it some sort of a side length. I don't have any numbers, so I'll say that every side is 2x. Okay? The only thing we know in terms of integers is f to the line segment LK, and that's 10. So I'll label that in there. This green line basically is 10. Okay? Now let's figure out what is it that they want us to solve. What is the volume of the cube? All right, so the volume of any cube is the sides to the power of 3. Now I've let each side equal 2x. So 2x to the power of 3 will be 8x cubed. So if I can figure out the value of x, I will be able to solve this question. All right, so let's start this question in terms of our equations, most likely a whole lot of Pythagorean relationships. Now, LK is the midpoint, right? L is the midpoint of AD and K is the midpoint of AB. So that means this is x and this is x. So the very first step in this question in terms of solving is going to be figure out LK, this segment right here. And we, of course, we're going to figure that out in terms of x. So if you look at that triangle, of course, this is a right angle. So that means x squared plus x squared is equal to LK all squared. So that means LK is going to be 2x squared under the square root sign, and therefore LK is root 2x. So I'll put that in there, root 2x. All right? Now the next one I will figure out is LF. Again, using Pythagoras, we know LF squared is going to be 10 squared plus, be careful, this segment right here is not root 2x, it's half of that. So it would be root 2x over 2, all squared. So this is 100 plus 2x over 4, 2x squared over 4. So that would basically be x squared over 2 plus 100, all under the square root sign, is equal to LF. And then I think I only have to do 2 more relationships. The next one involves this triangle right here, E, G, and F. In that triangle, we can label a few things first. We know that E to G is x, because it's basically the midpoint of this line, E is. And G to F is just the side of the cube, and we know that's 2x. So therefore we can solve for EF, and of course this is a right angle. So x squared plus 2x all squared is equal to EF squared, like that. And therefore we have x squared plus 4x squared is equal to EF squared. And therefore 5x squared is EF squared. And therefore EF is equal to the root of 5x. So I'll put that in there. And then we have one final relationship now, and that relationship involves triangle LEF. This big one in the middle. That will be our final Pythagorean relationship. Now first I'll write it in, and then I'll solve this. L to E is basically just the same as the side of the cube. So that's 2x all squared. E to F is root 5x all squared. And then L to F, we figured that out right here, is x squared over 2 plus 100 all under the root sign squared. So let's move this up. Now let's solve this. So we've got 4x squared plus 5x squared. Taking the square root of the root makes the radical sign disappear. And there you go. Multiply through by 2, get rid of that half. 8x squared plus 10x squared, x squared plus 200, like that. And then this becomes 18, and then if you subtract 1, you'll get 17x squared is equal to 200. X squared is therefore 200 over 17, and x is equal to the root of that. And in terms of a value, it's approximately 3.43. So great, we have x. Now we can figure out the volume. The volume, if you remember, was right here, 8x cubed. So the volume is 8x cubed. If you substitute x is equal to 3.43 and take the cube root, you will get approximately 322.8. 322.8 is the volume of this cube, and the nearest integer would be 323. So 25, the answer is A. In the diagram ABCD is a trapezoid with AB parallel to CD and with AB equal to 2 and CD equal to 5. Also, AX is parallel to BC and BY is parallel to AD. If AX and BY intersect at Z and AC and BY intersect at W, the ratio of the area of triangle AZW to the area of trapezoid ABCD is. So in this diagram, we're going to first label what we can according to the information they've given us in the question. They tell you that AB is equal to 2. CD, this whole distance at the bottom, is 5, so I'll write that there. And then they also tell me that AX is parallel to BC. And if that is the case, then that means that this is equal to 2, XC. So I'll put 2 right there. And then they also tell you that BY is parallel to AD. All right? And if that is the case, which it is, then AB is the same in terms of length as DY. So then that becomes 2 as well. And then therefore, YX, this little guy, is going to be 5 minus 2, so that's 1. Okay? Anything else that I can label? I don't think so. I think that's it. All right, now let's try to understand the question. They want the ratio of triangle AZW, which is AZW, this guy in there, okay, to trapezoid ABCD, and ABCD is the whole thing, the entire shape. Okay, so first what I'm going to do is just concentrate on the trapezoid. If you remember, the area of a trapezoid is the side at the top plus the side on the bottom divided by 2. So that in our case is 2 plus 5 over 2 multiplied by the height. So for example, if this is a trapezoid and this was A and this was B, and we had a height from one point to the other, and that was, say, H, our area is basically A plus B divided by 2 times H. All right? And this has to be parallel to that side for this to work. And in our case it is. They tell you that AB is parallel to CD. So AB is parallel to CD. All right? So this up here basically gives me, I think, just 7 over 2, right? 7 over 2H. Okay, well, that's pretty easy to figure out. But AZW, that's not as easy to figure out. That's going to be a little bit of a work here. Okay, so let's take this one step at a time. AZW is what we want, correct? Triangle AZW. And in staring at this for a little bit, I think I can see that that is going to be basically triangle ABZ, this guy right here, ABZ, and you're going to subtract from that ABW. Yeah, if you do that, you'll get AZW. So subtract from it triangle ABW like that. Okay, so here we go. Let's first start with trying to figure out ABZ, triangle ABZ. And in order to do that, I have to draw a height. Obviously, you know, to figure out the area of a triangle, you need height. So that first one, ABZ, I'm going to draw the height here. It cuts through right there. Okay? And that height, I'm going to cut into 2. This one from there to there, I'm going to call H1. And this one from there to there, I'm going to call H2. Okay? Now, in our trapezoid, we also labeled the height, correct? We labeled the height, we called it H right there. So I'll just draw that in for the sake of completion in the diagram. Okay? So that's my height. Now, do you notice something about H1 and H2? H1 and H2, if you add them up, they equal H. Correct? Okay? So that's the first very important thing that needs to be recognized. Now we get to the heart of the question, in my opinion, is that H1 and H2 have a relationship. If you take H1 and divide by H2, they equal something. And what is that? You have to look at the other sides. These triangles this one here, ABZ, and this little guy, XYZ, they're similar triangles. And because they're similar triangles, the ratio of the heights will be the same as the ratio of the sides. And in our case, we know the sides. Well, we know the bases at least. It's 1 and 2. So that means h1 over h2 is equal to 2 over 1. Okay? And then you just isolate for one of these. So this becomes 2h2 is h1, or h2 is equal to h1 over 2. All right? Then I'm going to plug that back into here. So h1 plus h2, which I got in terms of h1. And this becomes 3h1 over 2. All right? And therefore, h1 is equal to 2h over 3. All right? So I hope you followed that. I hope that isn't at all confusing, because it's not supposed to be. Now I can figure out the area of ABZ. So triangle ABZ, like any triangle, 1/2 base times height. The base is 2, and the height is h1. And this looks like 2 times 1/2, which is 1, which is h1, and h1 I just got right here. So it's 2h over 3. Okay? So that's about as far as I can go with ABZ. Now in a very similar way, I'm going to now concentrate on trying to figure out the height of this guy right here, ABW. So I will draw in that height. So I used a different color this time. And notice from here to here, that guy, I will just call, you can call it anything. Let's just continue our H theme, H3. And then from here to here, that one I will call H4. Okay? And in a very similar way, you will notice that H3 plus H4 is equal to H. So we got H3 plus H4 is equal to H. Be exactly the same as what we did here. Very similar, identical, I think. Now we have to understand that we can also create a relationship between H3 and H4. Why? Because we've got similar triangles again. ABW is similar to WYC, that guy. Okay? And if the heights have a ratio of H3 over H4, that is equal to the ratio of their sides, which are 2 and 3. So 2 over 3, like that. And if you cross multiply here, you get 3H3 is equal to 2H4. And therefore H4 is equal to 3H3 over 2. Okay? And then we substitute this finding back into here. H3 plus 3H3 over 2 is equal to H. And if you add this fraction, you'll get 5H3 over 2 is equal to H. And therefore H3 is equal to 2H over 5. And therefore now the area of triangle ABW is 1/2 base, which is 2, times the height, which is H3, and therefore that is 2H over 5. Okay? Now we have everything we need to figure out AZW. ABZ, which is right here, and ABW, which is right here. So triangle AZW is equal to triangle ABZ minus triangle ABW ABZ is 2h over 3. ABW is 2h over 5. Get a common denominator, multiply top and bottom here by 5, multiply top and bottom here by 3, and you'll get 10h minus 6h over 15, and that is equal to 4h over 15 of triangle AZW. So there you have it. We've got it all. If I can squeeze it into the same page, we've got ABCD, which here 7 over 2h, and AZW over here 4h over 15. So the ratio they wanted was the triangle AZW over ABCD, that shape that is essentially the entire trapezoid. Okay, we've got both values. 4h over 15 over 7 over 2h. Invert and multiply, and you'll get 4h over 15 times 2 over 7h. The h's cancel, and you've got just 8 over 7 times 15, which is 105. And there you have it. That's the ratio. 8 over 105, the ratio of triangle AZW to ABCD, the big trapezoid. So 8 over 105, they've just written it in a slightly different format. 25, the answer is B. In the diagram, right-angled triangles AED and BFC are constructed inside rectangle ABCD so that F lies on DE. If AE is 21, ED is 72, and BF is 45, what is the length of AB? So first and foremost, let's utilize the fact that these are right triangles to figure out some distances. AE, they tell us, is 21, and ED, they tell us, is 72. So we can easily figure out AD using Pythagoras. AD squared will be 21 squared plus 72 squared. Correct? And that looks like AD will therefore be 75 if you do that math there. So I'll just write 75 up here. All right, anything else that we can figure out? I think so. They give us that BF is 45, that distance right there. And we just figured out that AD was 75, so obviously BC will also be 75 since this is a rectangle. So that will also give us a Pythagorean relationship. We have BF squared plus FC squared is equal to BC squared. And BC is going to be 75 squared. FC is what we will figure out. And BF they give us in the question is 45 squared. So if you do the math here, you'll get FC is equal to 60. So I'll just put that there, 60, and BF they gave us in the question is 45. Okay? And I think that is the first part of the question. Pretty straightforward. Now, where do we want to go from here? At this point, I'm going to draw a perpendicular from the top all the way to the bottom. So that green line is going to be very important for us in this question. And I'm going to label some of these points here. Where it touches BC, I'll call it G, just to be consistent with our letters A, B, C, D, E, F, G. And where it touches AD, I'll call it H. Okay? All right. Now, this is going to be the heart of the question. The first thing, of course, is I want to concentrate on trying to figure out FG, that distance. So from here till here. Now, that can be done pretty quickly, considering the fact that you have this triangle here. And that triangle, the area can be calculated in two ways. The first way, of course, is 1/2 base times height, using 45 as the base and 60 as the height. So that's the first way, 1/2 times 45 times 60. And now another way is to use this as the base and this as the height, FG. So that would be 1/2 base, which is BC, and BC we know already is equal to 75, since that's a rectangle, and then our height is FG. Now these two ways of calculating the triangle's area are equal, right? Because the area is the same, regardless of which way you do it. So this will allow us to figure out FG. And if you do this math, you'll get FG is equal to 36. All right, so I'll put that 36 in there right there. Now I'm going to calculate F to H, that distance right there. If I can do that, then I can add it to my FG, and that will give me the length of AB, which is exactly what they want. Okay, now let's concentrate on FH. FH. Okay, so how do we do FH here? FH, I'm going to have to label a few things here, but fortunately they're not that complicated. This is a right angle right there. Okay, and if this is, say, angle theta, then this would be right here 90 minus theta. Correct? And in a very similar way, if you look at this triangle, just that one, this is also 90 minus theta. So I've got a similar triangle situation here. This triangle right here, which would be, I guess in terms of letters, DFH. DFH triangle is similar to this guy right here. That is what? ADE. ADE. And because they are similar, the ratio of the sides are the same. So here we go. FH, which is this side right here, so that's the side that includes 90 minus theta and 90, would be the same as this one, AE, in terms of the ratio. And that would be equal to the ratio of two other sides, so I'll use, say, HD, which would be the 90 and the theta side. And the 90 and the theta side on the other triangle is this one, ED. So HD over ED. There you go. And I think this should do it. Let's see here. FH, well, that's obviously what we're trying to figure out. AE, do we know the length of that? Yes, we do. It's 21. And then HD, from here to here, do we know the length of that? Actually, we don't. But it's okay, I can figure it out. HD would actually be the same as GC, correct? Since this is a perpendicular right there. And GC I can easily figure out using Pythagoras. It'll basically be GC is equal to 60 squared minus 36 squared, like that. Right? And that gives me GC is equal to 48. So therefore HD is also 48. So HD is 48, and I'll put that there. We're still continuing this relationship. And ED, well, fortunately, they give us that in the question. They give us that in the question stem, actually, 72. All right, we got it. So doing the math here, we get FH is equal to 14. And there you have it. We've got the full distance. They want you to figure out AB, correct? I think I can squeeze it in here. AB is equal to FH plus FG. And both of those we figured out. FH we figured out as 14, and FG we figured out as 36. And therefore 14 plus 36 is 50. So number 25, the answer is A. John writes a number with two 187 digits on a blackboard, each digit being a 1 or a 2. Judith creates a new number from John's number by reading his number from left to right, and wherever she sees a 1, writing 112, and wherever she sees a 2, writing 111. For example, if John's number begins 2112, then Judith's number would begin 111, 112, 112, 111. After Judith finishes writing her number, she notices that the leftmost two 187 digits in her number and in John's number are the same. How many times do 5 ones occur consecutively in John's number? So let's try to work with this. First and foremost, we've got John, and then we've got Judith, correct? Now we have to start figuring out what is John's number, and Judith's number we'll be able to figure out from what is John's number. So for example, if John's first digit is a 2 in the big long number, right? Judith will then write 1, 1, 1, correct? Entirely based on the question. When Judith sees a 1, she writes 1, 1, 2. When she sees a 2 in John's number, she writes 1, 1, 1. Okay? So 2, 1, 1, 1, immediately this doesn't work. Why doesn't it work? Because this sentence right here, after Judith finishes writing her number, she notices that the leftmost two 187 digits in her number and in John's number are the same. So when we write out all these numbers, we have to make them in a way so that they're always the same until we get to the two 187 digits. Now, I'm not going to write out all two 187 digits, but I'm going to try to see if there's a pattern here. So the only thing we figured out from this is that John's first number cannot be a 2. It must be a 1. Because if it's a 1, then Judith will then write 1, 1, 2. And so far, it matches. Okay? So if John's first number is 1, and then Judith writes this, then we then know then John's next number is also 1 and then 2. Why do we know that? Because the numbers always have to be the same for the first two 187. You got it? Okay. I'm just going to do a few of these. So here we go. All right, so here we go. So the first one is a 1. And we go on from there. Remember, this is John, and these numbers are Judith. Okay? So just top row is John, and below that are Judith's numbers. Okay? So entirely based on what the question told me, if it's a 1, it becomes 1, 1, 2. And if it's a 2, it becomes 1, 1, 1 for Judith's way of writing it. All right? So I'm just going to keep going in this way, and I'm going to write out a lot of them, and then I'll come back and I'll explain what's going on. So here we go. For John, I've written out quite a few, and I've also written out quite a few numbers for Judith. And I'm not going to write out all 2187, but I did write out 81 digits for John and 243 digits for Judith. And I did that to illustrate a certain pattern. Starting from the very beginning, his very first number, 1, and therefore Judith writes 1, 1, 2, right? That's the rule. And then since Judith's first three numbers are 112, that must be John's first three numbers, because the first 2187 digits for both John and Judith must be the same. So John has a 1 for the second digit, so therefore Judith again writes 112. But his third digit is 2, so when she sees a 2, she writes 111. And this pattern just keeps on going, right? This system, this rule. And that's what I did. These top numbers are all John, all these guys are John, and the numbers below them, those are all Judith. Okay? Now, what do they want in our question? What is it that they want? They want you to figure out how many times do you have 5 consecutive ones? All right, well, let's figure it out based on what I wrote. 5 consecutive ones. Okay, I see this is one scenario. That's 1, 2. This is for John, right? Not for Judith. So I've got 3, 4. Any more? 5 here. 6. 6, and it looks like it's the start of another one, but we only have 6 full ones. Okay? It doesn't give me too much help, but it sort of gives me an idea. That means when I've written 81 digits for John, I get 6 times where you have 5 ones. Okay? Now let's look at Judith. Judith, I've written out 243 for her. So it should be more, right? It should give us a better idea. Okay, let's see here. 5 consecutive ones. There's 1, there's 2, there's 3, there's 4, 5, 6, and then this one is 7. Do you see how that's 7? Because it's 111 here, but then it's 11 over there. See, I wrote it sort of like one on top of the other, but if this was all written out in one line, that would be 5 consecutive ones. So don't miss that. And then what are we up to here? 1, 2, 3, 4, 5, 6, 7. So this is 8, 9, 10, 11, 12, 13. Again, 14, okay? 15, 16, 17, 18, 19, and 20. Okay, that's a good number. So for 243 digits, you get 20 times that you have 5 ones in a row. All right, so at this point, what I did is I said, well, Judith's first 243 digits are the exact same as John's. Judith's first 2187 digits are going to be the same as John's. So if we have 20 in 247, then perhaps it will be the same in terms of a ratio for 2187. Well, let's see. 2187 divided by 243 is equal to what? Well, it's equal to 9. So for each 243 digit series, you'll get 11111 appearing 20 times. So that means since this is 9 times the length, it should be 20 times 9, which is 180. I hope you understood that. And then I went back to see the answer choices, and 180 is not one of the answer choices. So I thought, oh no, what do I do here? What did I do wrong? And the answer is I didn't do anything wrong. This is definitely part of it. You will get 180, but you'll get a few more. Why will you get a few more? Because eventually a couple more will pop up. Because eventually the key to understanding this question is that you get to a scenario like this, where you'll have ones at the very end. And when you match that with the next series, it joins to become one full 5-1 sequence. So that's a tough thing in this question. I really wish the answer was 180 so I could just circle it and move on with my life. But the fact that it's a few more than 180 is what makes this question difficult, and that's the part I have to explain now as to how many more than 180 are there. So to explain that, I've got to make a little bit of a table. So here we go. So I wanted to keep John and Judith's numbers, at least the first 81 digits for John and the first 243 digits for Judith in the screen. And then this table is going to be as follows. The first step, the length of each step, and then how many ones do we have in that step, how many twos do we have, and then what does that step end in terms of a number. Does it end in 1 or 2? And then how many of those 1, 1, 1, 1s do we have? What we're interested in. All right. So step number 1 is my very first one. Well, the length is just 1 digit, so that's 1. How many 1s do I have? Well, it was just 1, so I have 1, 1. How many 2s? Well, 0. It ends in a 1. And how many of these 5 1s do I have? Well, none yet. The next one is my 1, 1, 2, right here. Now, I can use John's or Judith's. I'll use Judith's because I've got so many more of hers. It's easier for me to look at that. So this is my step number 2 when I go to the next step, right? And this time, that 1, 1, 2 is step number 2, and the length is 3 now. Okay? 1, 1, 2 obviously is 3 digits. How many 1s are there in 1, 1, 2? Well, there's 2. How many 2s are there? Well, there's 1. And does it end in 1 or a 2? It ends in a 2. And how many of these 5 1s do I have? Well, 0 so far. Now the next step would involve 9. And it's these 9 right here. These guys right here. 1, 1, 2, 1, 1, 2, 1, 1, 1. Okay? So for those, that's the next step. It's a length of 9. How many 1s do I have? 1, 2, 3, 4, 5, 6, 7. How many 2s? 2. It ends in a 1. And how many of those 5 1 strings do I have? Well, none. It starts off with 1, like it's part of 1 is there, but there's no full 5 1s in a row. So the answer is 0, but in brackets I'll put like a half just to show that a part of it is beginning. All right, let's keep going here. Fourth step would involve 27 digits, so it's basically all these guys, these 27 numbers. And that would mean the number of 1s, oh boy, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And the number of 2s, 1, 2, 3, 4, 5, 6, 7. It ends in a 2, right? Because this is the last digit, it's a 2. And how many of these, how many of these 5 1s do we have? We've got 2 of them. We got 1 here, and we got 1 there. So finally, we have a few full ones. And then you just continue like this. But you say, well, okay, I understand that you're multiplying by 3 every time. So when you get to 81, it's going to be this whole, all of these, that's 81. But you really expect me to sit there and count all the 1s? And the good news is you don't have to. Here's a trick. The number of 2s is going to be the same as the number of 1s from the previous step. Let me repeat that. The number of 2s will be the same as the number of 1s from the previous step. Why? Because whenever you had a 1, you remember in our system, whenever Judith saw a 1, she made a 1, 1, 2 in her step. So every time there's a 1 in the next step, there's going to be the same number of 2s. So that means that the number of 2s at each step equals the number of 1s from the previous step. So using that very important piece of information, we can fill this in a little bit more quickly. Here, it's going to be 20 because the number of 2's at each step equals the number of 1's at the previous step. And therefore, since the length is 81 and 20 of them are 2's, the other 61 must be 1's. So that's just a subtraction. This one, have I got 81 in a row? Yeah, I got 81 in a row. So the last one is right here. It's a 1. Okay, and then how many of these 5 1's do we have in a row here? Let's see. 1, 2, 3, 4, 5, 6. 6 and a little bit of the 7th. So I'll put 6, and then I'll put sort of like 6.5 in brackets just to show that there's one that's about to start right here. You notice this one here? Okay, 7th step, again, multiplying by 3, 243. The good news is we do have the full 243 written out, and that's all of these guys. This one, and this one, all of Judith's basically. So the bottom rows. And that one, okay, I'm certainly not going to expect you to count the number of 2's, but you don't have to. It's the number of 1's from the previous row. So there you go. And this is just a subtraction now, 243 minus 61, which is 182. Okay? And then this ends, the very last one was a 2. And then how many do we have? Okay, this is the big one here. So we got 1, 2, 3, 4, 5, 6, 7, right? 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And remember, we had actually figured that out earlier, that it was 20. So put that in there. So this is 20, a full 20. Okay, now bad news is that for the next step, I actually don't have it all written out, and I'm not going to write out 729 of these. But we can use the system to figure out what these numbers are. Well, the number of 2's is the same as the number of 1's in the previous row, so this is 182. 729 minus 182, it's a subtraction question to get the number of 1's. This ends, well, by this point, it's 1, 2, 1, 2, 1, 2. So I'm pretty confident this is a 1. But this is the question right here. Well, it's 3 times the number of digits, right? This is 243, this is 729. So you would think it's 3 times 20. Okay, but here's the thing. The answer is 60. But because it ends in a 1 right here. That means when you get to the final, it's going to look something like this right there. It ends in a 1, so it's going to be part of the next 1, 1, 1, 1, 1, 1. So I'm going to put a little half like that. Does that make sense? I hope so. So, because that's the heart of understanding this question. That's how we're going to end up with more than 180. Remember, I got 180 before, but that's not one of the answer choices. All right. Hopefully the last one will put it all together. The last step is when you get to the full 2187. Remember, the number of 2's is the same as the number of 1's in the previous row. And then to get the number of 1's, you just subtract 2187 minus 547 is 1640. This is going to end in a 2. And this is the heart of our question in terms of our answer. What is that answer? Well, I previously got 180. Okay, this is where you get the final answer. So, here we go. Pay close attention now. For a string of 729, right? You have 60 of these 1, 1, 1, 1, 1, 5 1's in a row. For the next 729, again, you'll have 60. And notice what I'm doing. I'm putting a little bit of a half in brackets. And then for the next 729, you'll have 60 like that. Okay? 60 plus 60 plus 60 is 180. But there's these halves. And what does those halves represent? Do you remember? In my, diagram, they represent sort of 1, 1, 1 at the very end. And that will join with a 1, 1 at the beginning of the next string to create a 5 consecutive 1 sequence. So each of these will give you a 1, 1, 1, and then it will join with the 1, 1 from the next one. Does that make sense? And then similarly, from the next 729, it will be 1, 1, 1. It will join with the first 2 ones in the next sequence. And that's how you end up getting 2 more. So the final answer is 180 plus 2, which is 182. And that is the answer to this question. So I will admit this is difficult because I got 180 and then I couldn't figure out for the life of me how you could get more than 180. And I had to go through this entire system in order to get the final answer of 182. So it's difficult, but if you have some sort of a system, you should be able to figure this out. So number 25, the answer is A. How many 4-digit positive integers x are there with the property that x and 3x have only even digits? One such number is x equal to 8002, since 3x is 24,006. And each of x and 3x has only even digits. We have to have a 4-digit number. Now the first digit, our choices are either a 2, a 4, a 6, or an 8. For the second digit, our choices are 2, 4, 6, 8, but we can also use a 0. And similar for the third and last digit. So right off the bat, there's 4 choices, 5 choices, 5 and 5. And if you multiply this, you get the total number, which is 500. So that's obviously a very large number, far exceeding any of the answer choices. So there's got to be some strategy here. And it is, because this number is only looking at x. We also have to look at 3x, which is this number multiplied by 3. So the first thing I noticed is that if you have anywhere in the number a 4 and you multiply it by 3, that 4 becomes a 12. And that 12 has a 1, which is an odd digit. So we don't want any 4s. I also noticed that if you take 6 and multiply it by 3, you get 18. You get the same problem. So we don't want any 6s for now. Let's just look at clean cases. And therefore, the 4s are gone and the 6s are gone. So I can just use, for my first digit, I can only use a 2 or an 8 because the 4s are gone and the 6s are gone. Similarly, for the next one, I can use a 0, a 2 or an 8, and the same thing for the next 2 numbers, 0, 2, or 8. So that gives me 2 choices, 3, 3, and 3. And if you multiply this, 2 times 3 times 3 times 3, I get 54. Okay? I have 54 cases, and all of these, for sure, if I multiply any number that is made with those digits in that order, and I multiply it by 3, I will also get an even number. So for example, they give you 1 actually that's part of this 54, but let's just create another one. 2, 8, 8, 2. And if you take this number, this will represent, say, x. Now I want to see, what is 3x going to be? No problem. 2, 8, 8, 2 times 3 will be 8, 6, 4, 6. And that also contains only even digits. So any of these 54 will work. But as you can see from the answer choices are a lot bigger than 54. So there's quite a few that we have to find. So we have to do a little bit of thinking and figure out what are the remaining numbers. Now, this is going to be a scenario where we have to look at individual cases and see if each individual case works. Now, I think the 4s will never work, because if you multiply a number by 3, if you multiply 4 by 3, you get 12, right? So that's a huge problem, and we can't have that. But the good news is that if you put 6 and 8 together and multiply it by 3, it will actually work out in a way so that you get even digits. So for example, if you have just 68 by itself, right, and you multiply that by 3, what do you get? Well, you get 204. And 204, as you can see, has even digits. So we have to experiment now with 68. And I think, in my humble opinion, that is the most important thing to understand or figure out in this question, the 68 combination. And we will first experiment by placing it here. And therefore, in the first column, sticking to these rules right here, we will only have 2 and 8 as a possible choice, and we will have only 0 to 8 as possible choices here. So what I'm going to do is make a table, and here I'll make the list of the numbers, and here we'll write how many there are of that form. So using this system here, my list will be, for x, it will be 2068, 2268, 2868, and then using the 8s, we get 8068, 8268, and finally 8868. And the corresponding values for 3x are these numbers right here. So how many did I get? I got 6 additional values for x. So now let's figure out, how about if the 6, 8 went here? Well, for the first digit, I can put either a 2 or an 8. For the last one, I can put a 0, a 2, or an 8. And that gives me the following numbers for x. And the corresponding values for 3x will be those numbers. And as you can see, both x and 3x always have even digits. And I've got another 6 of those. How about if I put the 6, 8 here? And the last two, as before, 2, 8, and 0, 2, 8, and 0. And let's see what I get for x and 3x this time. And that gives me another 9 that satisfy the criteria. Now we come to the part of not 6, 8, but 6, 6, 8. If we have 6, 6, and 8, and we have either a 2 or an 8, that will also produce the required result. And those numbers are just 2668 and 8668. And if you multiply these numbers by 3, you get 8004 and 26,004. And those, as you can see, also all have even digits. So that's another 2. And then we have another scenario where the 668 is in the beginning, and that last digit is either a 0, a 2, or an 8. And this will give you 3 more numbers, 6680, 6682, and 6688. And if you multiply those by 3, you get 20,040, 20,046, and finally 20,064. So this gives you another 3. And then finally, you got 6668, and there's just one of those numbers. If you multiply that by 3, you get 20,004. And very last number is 6868, like that. And of course, that is just one number, 6868. And if you multiply that by 3, you get 20604, and that's just 1. So adding up the 54 plus all of these, you get a grand total of 82 numbers. And those 82 numbers satisfy the requirement that x and 3x all have even digits. So number 25, the answer is A. In the diagram, PQR is right angled at P and has PQ equal to 2 and PR equal to 2 root 3. Altitude PL intersects median RM at F. What is the length of PF? So they want you to find this length eventually. Let's begin. PQ they tell me is 2 and PR they tell me is 2 root 3. So very quickly using Pythagoras I can figure out RQ, right? So RQ squared is equal to 2 root 3 all squared plus 2 squared like that. So this is 2 times 3, which is 12, plus 4. So 16 is RQ squared, and therefore RQ is equal to 4. So label that right there, 4. And next we can figure out the length of PL, this whole distance right there. How? Well, the area of the triangle, the big one, the whole thing, PQR, can be calculated in a couple of ways. The first is by using this as the height and this as the base. And the second is by using that as the height and that as the base. And both of those, of course, will be equal to each other since they both represent the area. So the area will be 1/2 base, PQ, times height, PR, and that will be equal to 1/2 base times height, RQ, times PL. So the halves cancel. PQ is 2, PR is 2 root 3. RQ, we just figured out was 4, and then we just have PL left. So solving for this, PL is equal to root 3. Okay, so those are the first two findings in our question. Now, where do we proceed at this point? Now the question gets a little bit challenging, right? The first couple of things were pretty straightforward. What I want to find at this point is the length of RL from here to here. That's going to help me. So how do I do that? Well, we do that by understanding that we've got some similar triangles here. The similar triangles are the triangles RLP and PQR. Why? Well, because they share all the same angles, right? Because this is a right angle, and this angle is common to both. So therefore, the third angle in each of those has got to be the same. So if those two triangles are similar, which they are, the ratio of the sides will be similar. So RL over PL is going to be equal to PR over PQ. All right? So that means RL over PL, which is root 3, we just figured that out, is PR, which we know is 2 root 3. They've given that in the question. Over PQ, which is 2. They've also given that in the question. Solving for this, and we get RL is equal to 3. All right? So I'll just put that in here. I'm getting a collection of values. Well, we know that RQ is equal to 4. Well, if RQ is equal to 4 and RL is equal to 3, that means LQ must be 1, correct? That's just simple subtraction. So there you go. I got another one. Now where do we want to proceed? So far we're doing pretty good here. We want to go with another similar triangle situation, but this one is not as obvious, and this is, in my opinion, the harder part of the question. We've got to connect M to this side, and we've got to do it in a way that it's parallel to FL, so that this is a right angle. All right, so that's, I think, the key to the question here that allows you to sort of figure this out. And if you do that, you get a relationship between two triangles that are similar. And those two triangles are PLQ and triangle MXQ, right? PLQ is this guy right here, and MXQ is right here. And I'm labeling this X right there, that point that I just drew the line to. And therefore, the ratio of the size will be the same. So I've got MQ over XQ is equal to PQ over LQ. Okay? And let's see here, MQ. Do we know any of these? Yeah, MQ we know is 1, because remember they told you that this is the median. So if PQ was 2 and M was the median, then M to Q is 1. So we got 1 here. XQ, well, XQ we don't know yet. All right. And PQ is 2 and LQ we don't know. Well, actually, LQ we do know. Sorry, it's 1. All right, I was getting worried there. Okay, so XQ, that means we can solve, and if we do, we get a half. Okay, perfect. So we continue with our collection of distances. Eventually, the distance that we really need is FL. Once we get FL, we just subtract it from PL, and that gives us our FP or PF. All right, we're almost done. We have to now figure out MX. We got XQ, we have to now figure out MX. MX is this distance right here. Okay, that's pretty straightforward. That's, again, a similar triangle. MX over XQ is equal to PL over LQ. Same sort of similar triangles, ratios. So MX, XQ, we just got a half. PL is root 3. LQ is 1. So that means MX is equal to root 3 over 2. All right. We are continuing with our collection of data. And I think the only thing left at this point is just figuring out this distance right here, RX. RX, well, let's see. R to Q all the way down was 4, right? So RQ was 4. And then we just figured out that XQ is a half. So that means RX, this distance from R to X, will be 4 minus a half, which is 7 over 2. Okay? So we are one final similar triangle relationship away from figuring out FL, and then once we have FL, we can figure out PF by subtracting it from PL. And that final similar triangle relationship is as follows. It is these two triangles, RLF and RXM, right there. So we have RLF right here and RXM, this guy right here that involves X. Not all the way down to Q, but just to X. Those are similar. And therefore FL over RL is equal to MX over RX. And I believe we know all of these except FL. So FL over RL, which is, let's see here, 3. MX is root 3 over 2. And RX is 7 over 2. So solving, we get FL is equal to 3 root 3 over 7. All right. We are almost done. I think I can do it on this page. The final step, of course, is that PF, which is what they want us to figure out, is equal to PL minus FL. PL is root 3. FL I just got over here, 3 root 3 over 7. I can get a common fraction, 7 over 7, and if I do, that becomes 4 root 3 over 7. There you go. 4 root 3 over 7 is the answer to number 25, which is choice C. Starting with the input Mn, machine A gives the output Nm. Starting with the input Mn, machine B gives the output M plus 3N n. Starting with the input mn, machine C gives the output m minus 2n n. Natalie starts with the pair 0, 1 and inputs it into one of the machines. She takes the output and inputs it into any of the other machines. She continues to take the output that she receives and inputs it into any one of the machines. For example, starting with 0, 1, she could use machines B, B, A, C, B in that order to obtain the output 7, 6. Which of the following pairs is impossible for her to obtain after repeating this process any number of times? We have to look at how this behaves, and I'll just start off with a simple example. You can use any number. I'll use 3, 6. Let's say that is my initial mn. Okay, at the very beginning. Now, if I put this in machine A, it will give me the output nm, which in this case is just 6, 3. Now, what is important to look at in this question is factors. When you did this with A, the factors remain the same. In here, both 3 and 6 have a factor of 3, and here you just reversed it, so the factors remain the same. So both 6 and 3 have a common factor of 3 also. Now let's look at what happens when you put the same mn into machine B. Well, machine B turns it into m plus 3n and n. So m plus 3n is going to be 3 plus 3 times 6, and then the n just stays the same, so we have 6. So this is equivalent to 21 and 6. And as you can see, again, both 21 and 6 have a common factor of 3. And very similarly, we'll do the same thing with machine C. Machine C has the output m minus 2nn, and that would mean this will be 3 minus 2 times 6, which is 12, and 6, and that is, of course, equivalent to minus 9, 6. And again, both negative 9 and 6 have a common factor of 3. So, what does that show us? What does it mean? It basically means that the common factors stay the same after each output. So whether the output is nm, whether the output is m plus 3nn, or the output is m minus 2nn, the common factor will stay the same. And if you try any number, I just chose 3, 6, you can try any combination. You can try 2, 5, 6, 2, whatever. It's going to show the same. And most of the time, the common factor will be 1. Most of the time. Now, I don't know the exact percentage, but a lot of times, I think, for example, if you started with 3 and 5, 3 and 5 do not have any common factor except 1. So that's what I really mean. That sometimes, I should say, probably better choice of words, some of the time, the common factor will be 1. So that's the first part of the question I wanted to illustrate. Now, what we're going to do is really just look at the answer choices and work with those, because we have to eliminate one. One of these is impossible to obtain with a starting point of 0, 1. So let's look at the answer choices. Let's write them out. And each of these, what we need to do is look at what are its prime factors and then see which ones have a common factor. So 2009 is 7 times 7 times 41. And I'll do the prime factors for each of these. And when you break them all into prime factors, you will notice that only 2 of these actually have a common factor other than 1, right? Any 2 numbers are going to have a common factor of 1. But there's only 2 numbers that have a common factor other than 1. And that's 2009 and 1008. They both have a common factor of 7. And what I'm doing really is I'm comparing 2009 to any of these 5, right? Because if you look at our answer choices, 2009 has to be paired with one of those other 5. So that's what I really meant to say. The only of these 5 that has a common factor with 2009 is 1008. Only 1008 has a common factor other than 1 with 2009, and that common factor is 7. So that means that anytime you're going to go and make 2009, 1008 as an output, that means what you input, mn, these two numbers must also have a common factor of 7. But remember, we start with what? What is our initial pair that we're starting with? We start with the pair 0, 1. And if we're going to start with 0, 1, 0, 1, neither of these numbers has a common factor of 7. So since 0 and 1 do not have a common factor of 7, it is impossible to go from 0, 1 to 2009, 1008. All the others are possible because their only common factor, for example, if you paired 2009 and 1016, those two numbers, the only common factor is 1. And can you go from 0, 1 to this? Sure, because these two numbers also have a common factor of 1. Right? 1 is a factor of 1, obviously, and 1 is a factor of 0. I mean, 1 is a factor. 0 has anything as a factor. So that's basically how you figure this out. It's a little bit difficult. It's a little bit abstract, but I hope this makes sense. So the only one we were not allowed or not possible to get for this question number 25 was 2009 and 1008, which is D. Six soccer teams are competing in a tournament in Waterloo. Every team is to play 3 games each against a different team. Note that not every pair of teams plays a game together. Judine is in charge of pairing up the teams to create a schedule of games that will be played, ignoring the order and times of the games. How many different schedules are possible? We've got 6 teams, right? A, B, C, D, E, and F. 6 teams. And there's several ways, of course, but we'll just go in a logical order. We have A playing 3 games, and then similarly, all the other teams have to play 3 games, so B, 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 and so on. So let's just make this simple for us. Let's say A plays B, then plays C, and then plays D. Okay? That means so far A has played 3 games, so A is done. Now B has played 1 game already, so that is counted right there. But now B has to play 2 more games. And in a very similar way, C is right here. It's already played A, so 1 game has already been counted. C has to play 2 more games. So we've got a couple scenarios. The first scenario is when B and C and D, which is the same story. D has already played 1 more game. D has to play 2 more games. Those 3 teams that are right here, B, C, and D, don't play each other. If they don't play each other at all, then they must play the other teams, which are E and F. So that makes it pretty straightforward. B therefore plays E, and B plays F. C plays E, C plays F. And D plays E, and D plays F. So let's do the count here. B has played 3 times, B is done. C has played 3 times, C is done. D has played 3 times, D is done. And similarly, E, 1, 2, 3, F, 1, 2, 3. So all of these guys satisfy. So this is one possible scenario, right? Now, the good thing about this is that I chose A as my starting point, right? But what about this? This was B, C, D. This represents just one way of choosing 3 teams from the remaining 5. A is my starting point, and then I've got to choose 3 teams from the remaining 5. That was just one possible scenario. How many such scenarios are there? Well, from 5 teams that are right here, you have to choose 3. So it's 5 choose 3. And 5 choose 3, if you're not familiar with factorial notation or choose notation, it's 5 factorial over 2 factorial over 3 factorial. And that is equal to 10. So that means that this scenario that I just drew right here has 10 possible ways to create. So what I'm going to do on the side here is just sort of keep a little tally here of how many different cases. So we'll just call it tally. And so far we have 10. The answer choices are all greater than 10, so obviously we've got a little bit more work to do. But we have 10 so far. Okay, we continue with this question in pretty much the same way. Now we do the exact same story. We have 6 teams, A, B, C, D, E, F, and we want to create the same kind of story, so I'll write it all again. And again, just like before, I'll just put B, C, D here. It's any of those 10 ways is fine. But now the scenario is going to be different than this, and I'll explain that in a minute. Now we get to a point where we have to start talking about what do we do next. And before, B, C, and D don't play each other. That is the scenario that we chose. Now we choose a scenario where B, C, and D can play each other. So what I can do, A is already played 3 times, so A is done. B's played once, so this one is done. But now I've got to figure out, where do I go next? Well, I can let B play C, like that. There's only 3 ways that B can play C, or B could play D. Those 3 letters, in terms of B, C, and D, can only play each other in 3 ways, right? The first way, of course, is what I just drew, which is BC. And the other way would be, of course, BD. And of course, the other way is CD. So this gives me 3 possible paths that I can take, starting with one initial path. So that means that of all these 10 initial paths, I've got 3 more branches. And those branches are this guy, and this guy. So right off the bat, I've got 30 different paths that I have created, and each of those creates a new schedule of games. Okay, so I hope that makes sense. I'm just going to concentrate on this one right here, BC. Now at this point, what do we do for B? B, can it play D? Because it has to play one more, right? Because I've got so far that B has played 2 games. This one here and this one here. So it's got to play one more. But can it play D? And the answer is no, because if you try that scenario, what will end up happening is that the E's and the F's are left in a situation where it's impossible for them to play 3 games. So that means that B and C, the only thing we can do is have them play E and F. So we'll just create one such scenario. You can have B play E, and when you do that, B is done. You got 3 games for B right there. And then we continue. C has already played A here, and C has already played B there. So C's done, but we got one more game for C. Make it play F. All right, so C's done. 1, 2, and 3. Now D already played A here, so we don't need to talk about that guy. But then D will obviously have to play E and F to pick up 3 games. And then so far we have, let's see, E and F have already played 2 games each. So obviously they need 1 more game, and therefore E will play F. And that's it. E is 1, 2, and 3, and F is 1, 2, and 3. So this scenario is great. It all matches up. So what I did up here was I created the scenario BE and CF, if you notice. There's one other scenario that is just switching the F's like this, BF and CE. So what this does is it gives you 2 possible directions of these 30. So my tally now is 30 times 2, which is 60. So recount the totals. From this scenario where B, C, and D don't play each other, we have 10. From this next scenario where B, C, and D can play each other, we have 60. So the total is the 10 up there plus the 60 down here, and that is 70. So the answer to this question is 70, and number 25, therefore, is E. Dolly, Molly, and Polly each can walk at 6 kilometers per hour. Their one motorcycle, which travels at 90 kilometers per hour, can accommodate at most 2 of them at once and cannot drive by itself. Let T hours be the time taken for all 3 of them to reach a point 135 kilometers away. Ignoring the time required to start, stop, or change directions, what is true about the smallest possible value of T? We have to develop a strategy to figure out what is the way that they're going to travel. And I think that is the most challenging part, figuring out the strategy. Once the strategy is figured out, then the math is relatively straightforward. So here is the strategy. So I'm going to draw a few lines and then explain it. So the 3 friends, D, M, and P, all obviously start off at the start, and this whole distance is 135 kilometers to, I guess, the finish line. We can call it finish. And the strategy is as follows. First, 2 of them, let's say Dolly and Molly, get on a motorbike, and they go all the way to a certain point. They get to here. So D and M arrive here. Meanwhile, Polly is walking. So Polly is not staying here. She's walking. So she's somewhere around here. Okay? Now, at this point, we don't know any of these distances. So I'm just going to label this distance X. It's the distance from that point to the finish. Now, this is a very important point. That is what you call a drop-off point. And that is where Dolly drops off Molly. And then Molly starts to walk in this direction. So Molly will start walking toward the finish line. But then Dolly goes back to pick up Molly. Okay? So now Dolly's coming back. And by this point, Polly is walked till about here, right? And then Dolly comes back to pick her up. So this is now a pick-up point. Now the distance that Polly has walked from the start to there, I don't know, so I will call it Y. Okay? Meanwhile, Molly is still walking. She is probably pretty close to the finish line. Not sure where, but somewhere around there. Then Dolly picks up Polly and then drives her back on the motorbike. So then they all go back together, and eventually they end up at the finish line. So they all end up back at the finish line, P, D, and M. Okay? And they all arrive at the finish at the same time. So let's figure this out. And we're going to use, of course, that formula, speed is equal to distance over time, and any variation of this formula, such as time is equal to distance over speed. So let's figure this out. Let's call this first scenario T1, and then this second scenario we'll call T2, and then this final scenario we'll call T3. And then, of course, the t is the time taken for all three of them to reach point, I guess the finish line. So that t that they're asking about that's in the answer choices is really t1 plus t2 plus t3, because all of them have to reach the finish line. So here we go. What is t1? Well, it's distance over speed. And for this distance, it's from there to there. Now the whole distance is 135, and from here to here I have labeled that as x. So that distance that the two friends on the motorbike travel from there to there is really just 135 minus x over 90, which is the speed. And then for Dolly, which is the first friend that I really am talking about, T2, her T2 is basically going from that drop-off point back to the pickup point, right? She was here, but then now she's traveling to there. So she goes back like that. So that distance is basically 135 minus x minus y. And again, over 90, because she's still on the bike. And then the last distance is when she goes from the pickup point right here all the way to the finish line and ends up here. So that is going to be 135 minus y all over 90. All right. So I hope that makes sense. Those are the three times for Dolly. And the total, of course, we need to figure out. But the only way we could figure out the total is if we had actual numerical values for x and y. And we don't. So what do? Well, if we don't have that, we have to come up with new equations. We have to come up with additional equations that will allow us to figure out the values for x and y. And how we do that is by looking at the other friends. We'll look at Molly, and then we'll look at Polly. So in the very same way, let's look at Molly. What is her story? Well, Molly initially was on a motorbike until the drop-off point, so that's going to be 135 minus x over 90. Now let's talk about T2 for Molly. Interestingly, for Molly, T2 and T3 is sort of the same because that whole time she's just walking. So we actually don't even need to worry about two different times. We should just concentrate on her second phase, which is just walking, and that's just x over 6. The distance is x and the speed is 6 because they're walking at 6. So that's all there is for her. And then Polly, her T1 is that initial phase where she's walking, so that's actually going to be just y over 6. And then her final phase is when she's on the motorbike and going all the way to the finish line with Dolly, and that is 135 minus y over 90. So there you go. This is a breakdown of all three friends. Now we still haven't figured out the numerical values for x and y, and that's obviously required. So how do we do that? Well, we do that by looking at the times and comparing them. So for example, after this drop-off point, the time it takes Molly to go from the drop-off point to the finish line is this right here, x over 6. But that is the same amount of time it takes Dolly to go all the way back to the pickup point and then back to the finish line. So remember, they all arrive at the same time. So that means this is equivalent to this plus this. Okay? That's very important to this question. So 135 minus x minus y plus 135 minus y, these are both over 90, is equivalent to x over 6. Those times are the same. And in a very similar way, we can compare Molly and Polly. Comparing Molly and Polly, their total times are the same. The time it takes Molly to be on the bike and then walking is basically her entire journey, is the same amount of time as the entire journey for Polly, which is an initial walk and then a motor ride. So that means that 135 minus x over 90 plus x over 6 is equivalent to y over 6 plus 135 minus y over 90. So there we go. We got two equations, two variables. We can now solve for x and y. So let's proceed, and then we can come back and figure out the time, which is right here. Well, this equation, let's start with that one first. Let's multiply through by 90. That will get rid of the fraction. So we have 135 minus x minus y plus 135 minus y. If you multiply this by 90, it becomes 15x. And then let's put everything on one side. 270 minus 16x minus 2y is 0. So if I isolate for y, I get 270 minus 16x. Divide through by 2, you get 135 minus 8x. Okay, let's solve this one right here. Divide or multiply through by 90 and you get 135 minus x plus 15x plus 15y. And that's going to be just 135 minus y. So the 135's cancel, and we got 14x is equal to 14y. So that means x is equal to y. Oh, okay, interesting. Substituting that back into here, and we got 135 minus 8x is equal to y, but y is equal to x. So that means 135 is equal to 9x, and therefore x is equal to 15. And that means y is equal to 15. Okay. There we go. I just got numerical values for x and y. Now I can figure out my times. So keeping this in mind, that t is equal to t1 plus t2 plus t3. Let's just use Dolly since Dolly has t1, t2, and t3. So that's going to be 135 minus x over 90. Well, x is 15, so that's going to be 120 over 90. T2 is this 135 minus x minus y. Well, x and y are both 15, so it's 135 minus 30, so 105 over 90. And then finally, this guy, 135 minus y, so that's 120 over 90, since y was 15. And that is, in terms of decimals, a 1.33 plus 1.166 plus 1.33, and if you add it all up, it's approximately 3.83. So that is the shortest. The strategy was to figure out the shortest, 3.83, and therefore t would lie in which interval? A, right here. So like I said, the strategy, which is this diagram right here, is the challenging part of the question. Once you get the strategy, then you just use this formula to figure out what is the smallest possible value for t, which is the time. Number 25, the answer is A. There are 4 people in a room. For every 2 people, there is a 50% chance that they are friends. 2 people are connected if they are friends, or a third person is friends with them both, or they have different friends who are friends of each other. What is the probability that every pair of people in this room is connected? We have 4 friends. I'll call them A, B, C, D. And there's the following pairs. We have A and B, A and C, A and D, B and C, B and D, and finally C and D. Those are the 6 possible pairings. And now we have to figure out if they are connected or not. And the best way to do this question is with diagrams. So I will explain all the diagrams. And we're going to make a little bit of a table here. The first table is going to involve whether or not they are all connected or not, and if so, how many friendships are involved. So hopefully this will become clear as I explain it. So the first question is, all connected? Yes or no? The next is the number of friendships. So let's start off with the most basic one. And I'm going to draw a diagram to illustrate it. So this doesn't have to be a work of art. So here we go. The first one is if you have all 6 friendships, meaning all of them are friends with each other. So all of these are basically friends. Now that can be illustrated really nicely in a diagram as follows. You make a little box like this, and each of these represents a friendship. So this is friend A, B, C, and D. If 2 people are friends, they will be connected to one another. So A and B are friends, and as you can see, there's a line between them. A and D are friends, there's a line between them. B and C, C and D, D and B, A and C, all of them have a connection. That shows that they're all friends. That's what this diagram hopefully is showing. So there's 6 friendships, and all of them have a line with each other. 1, 2, 3, 4, 5, 6 lines, 6 friendships. And are they connected? The answer is yes. They are connected. They satisfy at least one of these. Okay, so that is just kind of simply explaining it. Now, if you're still not convinced, I'll break it down a little bit further, one at a time. So first I'll start with the first one. If 2 people are friends, how can you be illustrating them in a diagram situation? Well, if 2 people are friends, you just draw a line between them. And let's say those 2 people are A and B. There you go. That takes care of this one for our diagram purposes. The next one is a third person is friends with both of them. So they're not friends. So you got a situation where you have A and B. They're not connected. There's no line between them. But there is a third friend that they're both friends with. So let's say it's C. So there will be a line from B to C and A to C. That is what this is describing, the second one. A third person is friends with both of them. C is friends with A, is friends with B. But B and A are not friends with each other. But it doesn't matter for our connection purposes. This is still qualifies as connection. It is in the definition here of being connected. The third scenario, they have different friends who are friends of each other. Okay, what does that look like in a diagram? Well, let's draw it. Here's A, B, C, and D. It looks like the following. A and B are not friends, but A is friends with D. B is friends with C, but D and C are friends. Okay, that takes care of the third guy. So anything that looks like that means that A and B are connected. So it's pretty obvious that this satisfies pretty much, this sole first one by itself. We don't even need to worry about anything else. Okay? So if you get that, if that is clear, let's move on. Now we move on to the next scenario. The next scenario is where the number of friendships are 5. And what that basically means is that instead of 6 lines, 1, 2, 3, 4, 5, 6, we're only going to have 5 lines. So 1 line will be missing. And what that basically means is that out of the 6 lines, you choose only 5 of them. So let me repeat that. In the first diagram, you know how you had 6 lines, 1, 2, 3, 4, 5, and 6. We only want 5 friendships. So instead of 6 lines, we want 5 lines. So out of the 6 lines, I choose 5. This is what that means. 6 choose 5. And 6 choose 5 is 6 factorial over 6 minus 5 factorial over 5 factorial. And if you do the math, that just comes out to 6. Okay? So there's 6 ways of having a situation of only 5 friendships. Now, if you do that, are they all connected? Well, let's see. Let's draw a diagram and see. Diagram, I will draw and then I will explain it. So this is going to be our diagram. And I only want 5 lines. So far I've drawn 4. Here's a 5th line. Does this connect everybody? If they're connected, they will be joined in some way. You'll be able to get from one friend to the other friend somehow. Like for example, in the first one, if because A and B are joined directly, you can get from A to B on that line. But in the second one, A and B are not joined, but you can get from A to B through C. In the third one, A and B are not joined, but you can get from A to B through D and then through C. So they are connected if you can get from any one to another one through some path. And you can get from A to D, you can get from A to B, you can get from A to C, and so on, right? I mean, this basically means that everything is connected. So the answer here is yes. So far, there was only one way of making that box. So that's 1. There's 6 ways of making a situation where you have only 5 sticks, 5 connections. So that's 6. Okay. Now, some of you might say, well, I know another way of drawing this diagram. What about if you had something like this? And then you drew the sticks like this, the 2 diagonals, but then you got rid of 1 stick like up here. That's a way of making 5 sticks, and you're absolutely right. If you came up with that way, that's definitely a way of doing it. In fact, there's 2 ways of making this box and 4 ways of making that box. So that's why the total is 6. Okay, so far so good. Let's move along. Now the next one is 4 friendships. So what that means is instead of 6 sticks, I want 4 sticks this time. In a very similar way, from 6 possible sticks, you would choose 4 this time. And that is 6 factorial over 6 minus 4 factorial all over 4 factorial. And when you do that math, you get 15. So we got more here. We got 15 ways of making a diagram that has only 4 sticks, and that represents 4 friendships. Now, are they all connected though, if you have 4 friendships? Well, let's see. Let's draw some possibilities. Let's draw this one here. That's 4 sticks. Are they all connected? Can you get from any one of these to the others? And the answer is sure you can. That's definitely a connection. How about another diagram that has 4 sticks? Something like this. 1 stick across the middle, like that, but then 1 stick removed from one of the sides. That's 4 sticks, right? 1, 2, 3, 4. Is this connected? A, B, C, D. And the answer is yes. You can get from any letter to any other letter with a path. If you want to get from A to C, you can. If you want to get from A to B, you can. So this is also connected. So I encourage you to kind of go through this on your own and convince yourself, just don't, take it at face value. So this is also a yes. Now we get into the stuff that is a little bit more trickier. Now, I want to just take a pause here and say that these 15, there's a few more diagrams. I'll let you do that. I want you to come up with the other diagrams, but I will guarantee you that all 15 of them will be able to show connections. And those other diagrams, you know what? I'm a nice guy. I'll give you a hint. There's another one that has basically the 2 diagonals, but then you're just removing 2 sides like that. That's 4 sticks, right? 1, 2, 3, 4. And then there's others as well. And like I said, I want you to do that instead of me having to spell everything out for you. Okay, now we get to the last 3. The last 3 are where the question really not necessarily becomes extremely difficult, but that's how you're going to arrive at the right answer. Now I'm going to do the last 2 first, which is number of friendships is going to be 3 and 2 and 2, and 1, and 0, right? Those are my possibilities. Well, with 0, what that means is that basically you have just 4 dots, A, B, C, and D, and there's no sticks. Like that. No sticks. So are they connected? Well, definitely not, right? But how many of these do you have? From 6 possible sticks, you choose 0. And 6 choose 0 as 1. But that doesn't need to be counted because they're not connected. How about if you have one friendship? One friendship is a very easy diagram to draw. It's A, B, C, D, and you just have one stick. So somewhere, is this connected? Well, no. D and C are not connected, and D and A are not connected. How do you do that? From 6 sticks, you choose 1. And there's 6 ways of doing that. But it's not connected. How about 2 friendships? 2 friendships, again, pretty easy to draw an example. A, B, C, D. I got to use 2 sticks. How about that? That and that. That's 2 sticks. Are they connected? No. A is not connected to D. C is not connected to B. How many of these? From 6, you chose 2 sticks. And 6 choose 2 is 15. Now we get to the heart of the question, which is 3. 3 friendships is what decides whether you're going to get this question right or wrong. 3 friendships, and I think I'm going to need a little bit more space, so I'll move it over, has 5 different scenarios, unfortunately. So I'll draw them out. We got this one, and then, well, obviously I'm going to have to edit these. Okay, so the first one is 3 sticks, like that. Now, are these connected? Well, you tell me. If this is A, this is B, this is C, and this is D, is everybody connected? Think about it and let me know. And the answer is yes, they are, right? Because you can get from A to D, A to C, A to B, in any sort of path like that. So there's 4 of these guys. Now, what is the total? I didn't do that yet, right? 6, it's going to be from 6, choose 3, if I'm following the same pattern as all the other ones. And 6 choose 3 is equal to 20. So I have to figure out of these 20, how many of them are going to have a yes. And then some of them are going to have a no. This is the only one that splits up into yes, no, which makes it kind of challenging. Okay, let's move forward. Let's go to the next one. The next one, I just do a box, but that's not what it looks like because obviously that's too many sticks. The next one, what I really meant to draw is this. 3 sticks like that. So this is A, B, C's out here all by itself, and then D. Are these connected? And I am certain that you by now will be able to figure out that no, this is not connected. Now, how many ways of making these? There's 4 ways of making something like this, right? So these 4 are not connected. So the ones that are connected, I will circle. Okay, now let's go to the last 3. The last one is going to have basically a scenario like this, where you draw that and you get rid of those 2. So that means you have now 3 sticks, correct? So this is A, this is B, this is C, and this is D. Is everybody connected here? And the answer is yes, they are. So here's another 4 that's connected. The second last one is going to look like this, but I can only have 3 sticks, so I've got to get rid of a few. Got to get rid of this one, and I'll get rid of this one. So it becomes sort of a Z pattern. And are the Z patterns connected? Well, let's see. A, B, C, D, and the answer is yes. So this gives me 4 more. And then the very last one, that one is going to look like this. You're going to have 2 diagonals, but I've got to get rid of one. Actually, got to get rid of 3. and get rid of this one, and this one. There you go. So it becomes sort of an X with a hat. And let's just label this. So this is A, B, C, and D. Are these connected? And the answer is yes. So of these 20, the only ones that were connected are this 4, this 4, this 4, and that 4. So 16 of them are yes. And this guy is a no. All right, so that's what I'm going to circle. So now what we have to do is count up all the yeses and then divide by the total. So I think I can do that. Let's just do it here, keep myself on the same page. So in any probability question, the denominator is the total. So what's my total, first of all? Well, I got 1, 6, 15, 20, 15, 6, and 1. Those are my total cases. When you add that up, you get 64. So that's my denominator. Numerator is the yeses. So this was a yes, that's 1. This was a yes, that's 6, we're up to 7. This was a yes, that's 15, we're up to 22. This one was a yes, 16. So now we're up to 38. And that's it, right? Yeah, that's it. Because everything else was a no. This is no, this is no, this is no, this is no. So 38 is my numerator. And that's the answer, 38 over 64. I think they've lowered it to lowest terms, 19 over 32. So let's go back, 19 over 32. For number 25 would be choice D. The GEB sequence 1, 3, 7, 12, ... is defined by the following properties. The GEB sequence is increasing, that is, each term is larger than the previous term. The sequence formed using the differences between each pair of consecutive terms in the GEB sequence, namely the sequence 2, 4, 5, is increasing, and each positive integer that does not occur in the GEB sequence occurs exactly once in the sequence of differences in 2. What is the 100th term of the GEB sequence? Okay, let's explain this. So first and foremost, they've given us part of a sequence that's called a GEB sequence. And then they're saying that when you take the differences, that creates another sequence. So the differences, for example, 3 minus 1 is 2, 7 minus 3 is 4, 12 minus 7 is 5. So this sequence is called, I guess, sequence 2. It's the second sequence. And then what they're saying is that eventually every number, 1, 2, 3, 4, 5, and so on, every number, every positive integer that is not in here will occur in here. So if it's not in the GEB sequence, it will be in this sequence, which they have called the sequence of differences. All right. Okay, so that's basically how this is going to go. Now, you say, well, okay, well, how do I approach this? Okay, well, what I'm going to do is I'm going to first write it out, and I'm going to do it in a way that hopefully explains it thoroughly. And once it's explained thoroughly, then I think you will be able to find out a shortcut on your own. If I give you the shortcut immediately, then it won't make sense. But if I explain it thoroughly, then you'll say, oh, okay, I know how to do this. So that's my goal. So here we go. We have to now continue with this GEB sequence, but how do I do that? I'm not really sure, right? So let's just write out the numbers. Let's write out, say, the first few numbers. And now what we will do is we'll attempt to make this GEB sequence. We'll continue it. All right, here we go. Well, the very next one, what do I put here? Well, my goal is to ensure that every single positive integer is used. Let's circle the ones that have been used so far. We've used 1, we used 3, we used 7, and we used 12. And in a different color, let's circle the ones that make up this other sequence. And remember, this is the GEB sequence. And the one up top is the sequence of differences. That's why I put diff for differences. Okay, the sequence of differences so far has used the 2, has used the 4, and used the 5. Now I've got to ensure that every single one of these integers, it belongs to either the GEB sequence or the diff sequence. Okay, well, let's go in order. That means the next one got to be 6, right? But I can't put 6 there because the sequence has to be increasing. So the only way I can put a 6 is I put it up there in the differences of the sequence of differences. You see what I mean? Okay, so that takes care of the 6. Well, what is this number then? Well, it's got to be 18 because that's how you get the 6. That's what 6 means. It's the difference between those two. And that's why I drew a little arrow here. See? Okay, so 18 is in the GEB sequence, so let's circle that. And then we just keep going like this. So the next one, I'm going to choose the 8. So I'm going to put the 8 in there. So let's put the 8 up here. And therefore this number here has got to be 8 plus 18, which is 26. So the 26 goes. In the very same way, I keep doing this. And the next one is a 9, so that means the 9's got to go here. And therefore the next number is 35. So the 9 and the 35 are now used. The 9 went in the sequence of differences, and the 35 went into the GEB sequence. Okay, so this is basically the process. I'll write out a few more. I'll talk you through a few more, and then I'll write out all of them, because you certainly don't want to hear me talk through every single one. I mean, it would be ridiculously painful and boring. So I'll just draw out a few more. So the next one is what? 10, right? So I'm running out of space, so let me draw it on a separate line. I'm down to 35 for my GEB. And the next one is 10, so that means this is 45. So 45 has now been used, and for the diff, I use 10. All right, let's keep going. I'll do just a few more. The next one, of course, I've got to use 11, and then once I do, that becomes 56. So 56 has been used, and so has that 11. Okay, what's my next number? Well, I can't use the 12 because the 12 has already been used. It was in the GEB sequence here. So I got to skip over that, use 13 now. Okay, put the 13 in here, and that means this number is 69, right? 13 plus 56. So the 69 has been used, and so has the 13, which is right here. And then you just keep going like this. So at the very end, if you keep going, you will see that the final number, the 100th number that they're asking for, is going to be the sum of these guys. It's going to be the sum of a lot of these numbers, right? And as you can see, it looks like they're pretty much consecutive except the numbers here. See what I mean? Those are the numbers that you're not adding. But perhaps that is not so clear at this point. So I'll just keep going. But what I'll do now is I'll just write them out instead of walking you through it. So here we go. And that's a few more. So now I'm going to circle the ones. I've got to circle 14, 15, 16, and 17. And then for the GEB sequence, I've got, 69 I've already circled. 83 I haven't even put. But 83, 98, 114, and 131. So as you can see, it's getting pretty big there, right? Okay, so now let's talk about this. Now you don't have time to go through all 100 because this was the first, this is the second, this is the third, fourth, fifth, sixth, seventh, 8th, 9th, 10th, 11th, 12th, 13th, 14th. We're only up to the 14th. Now we have to get to 100, but I do not advise you to do this process until 100. That would take forever. So what you have to do is come to a conclusion as to how this is proceeding. Basically, what you're doing is you're adding all the numbers. I took 1, I added to it 2, then I added to it 4, then I added 5, then I added 6, then I added 8 and 9, and that's how we're getting to these numbers. It's basically a sum. Then I added 10. That's how I got 45. Then I added 11. That's how I got 56. So essentially, you are adding all these numbers, right? And eventually, dot, 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 you're going to get to some big number, which will represent my 100th number. And that number, whatever you want to call it, so let's say it's n, is essentially the sum. It's the sum of this 1 plus this 2 plus that 4 plus that 5 plus that 6 plus that 8 plus that 9 plus the 10 plus the 11, right? You get the hang of it, right? All of those. 16 and so on, 17. Dot, dot, dot. All the way. Now you say, okay, well, that I get it, but I still don't understand how can you figure out n? Well, this is what you have to conclude. What is happening really? Basically, what you're doing is you're just adding all the numbers, right? All the consecutive numbers, dot, dot, dot. But you're subtracting from it the numbers in the GEB sequence. You have to add these consecutive numbers, but you have to subtract from it the numbers in the GEB sequence. So you cannot put the 3, you cannot put the 7, you cannot put the 12, right? You cannot put the 18, you cannot put the 26, you can't put the 35, you can't put the 45, you can't put the 56, or the 69, or the 83, or the 98, and so on. You say, well, okay, well, when do I stop here? Well, that's it. That's when you stop. You say, well, how do you know that? Well, because you only have to go up to 100 numbers. And if you go up to, how many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And if this went up to 111, then 111 minus these 11 would be 100. It'd be 100 terms. And that's how you get to that. So a little bit of thinking involved, but it's actually not too bad. And I hope this explains it. So now all we have to do is figure out this sum. Okay? Well, this first part is just the sum of consecutive numbers, and there's a formula. If you have 1 plus 2 plus 3 dot 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 all the way until n, some of you know this, it's n times n plus 1 over 2. That's a quick formula. So using that will be 111 times 112 over 2. And then these guys, you just have to manually add them up. And when you manually add up those 11 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, it's 452. So this is 6216 minus 452. And when you do that, you get 5764. That is the 100th number. So that's the number that you're going to get right there. 5764. And therefore, the answer to this question, 5764, number 25, that would be E. Suppose that 2009 over 2014 plus 2019 over n equal a over b, where a and b and n are positive integers with a over b in lowest terms. What is the sum of the digits of the smallest positive integer n, for which a is a multiple of 1004? 2009 over 2004 plus 2019 over n is equal to a over b. Let's add this fraction. So I have 2009 n plus 2014 times 2019 over 2014 n is equal to a over b. Now, since a over b is in lowest terms, we can conclude that the numerators, which are 2009n plus 2014 times 2019, is equal to some sort of multiple of a times k, let's say, and the denominator, 2014n, is also some multiple of b. And that's why when you were to put the numerator over the denominator, they would be equal. So that is our first conclusion that we can make, and hopefully this will help us in the long run. They tell me that a is a multiple of 1004. Well, if that's true, and ak is equal to this whole thing, then that means this part must also be a multiple of 1004. So essentially what we can do is just write that expression as a multiple of 2004. So whatever letter you'd like to use, 1004 times m, let's say. Okay? All right, so this is a basic sort of beginning to this question. Now let's work with this expression right here. Let's multiply it out. So it's 2009, and then when you multiply 2014 times 2019, you get 4066266. Now it is some multiple of 1004. Okay, so I've got to make it look like that. Okay, well, I think I can do that if I break things up a little bit. This 2009, I'm going to break up into 2008 and n. And this 4066266, I'm going to break up into some multiple of 1004 and whatever is remaining. And I can do that as follows: 4066200 plus 66. If I do that, I will be able to factor out a 1004 from this to make it consistent with the fact that it's a multiple of 1004. 1004 divided by 2000 into 2008n would give me 2n. And then this number, if I divide that by 1004, I get 4050. And then I've got this 66 plus n left over. So at this point, you can conclude that this is obviously in the form that we want, right? This form. But this isn't. So that means the only way this could be a multiple of 1004 is if this is a multiple of 1004. We need to have 66 plus n to be a multiple of 1004 for this to be valid, for this to work out. What that really means is that 66 plus n is 1004 times some letter, let's just say k. All right, so isolating for n, it's 1004k minus 66. So this is basically the form that n is in. We still don't know what is the actual value of n, but that's the form that it's in. Okay, that's pretty good. Now all we have to do is sort of fiddle around with this and see what we get for n. So let's start with the basic one, k equals 1. When k equals 1, n will be 1004 minus 66, which is 938. What we have to show now is this n chosen in a way that it makes the value of a multiple of 1004, which is the criteria of the question. Okay, let's see. For 938, let's see what a over b becomes. Well, remember, it was 2009n plus that 2014 times 2019 divided by 2014n. When you substitute n is equal to 938 and you multiply it all out, you get 5950708 over 1889132. Now, they told me that this is in lowest terms, so I'm going to try to get it close, not necessarily in lowest terms, but at least try to see what I can do. If I divide top and bottom by 4, because both of these look like they can be divisible by 4, I get 1487677. 472,283. Now, regardless of whether this is in lowest terms or not, at this point, I can test it. I can see this is my candidate for A. Is this divisible by 1004? Is it a multiple of 1004? And the answer is no. When you take this number and divide by 1004, you do not get an integer. So, A is not a multiple of 1004 here. Okay, no problem. Let's keep going. This one was for k equals 1, so let's try for k equals 2 this time. When you substitute k equals 2 into here, we get n is equal to 1004 times 2 minus 66, which is going to give me a value of 1942. Okay, so now let's figure out our a over b. Same thing, substitute n into that. And when you do, and you multiply it all out, you get 7967744 over 3911188. Let's divide through as much as we can to get it in not necessarily lowest terms, but lower terms. And when you do, you get 1991936 and 9777797. Now let's test it out. Let's take this number, which is my candidate for A, and let's divide by 1004. And it works out. This number is basically 1984 times 1004. And also, interestingly, this fraction is in lowest terms. So that really strengthens our argument that this is our number for n. And therefore, since we have found our n, now we have to find the sum of the digits of n. And that would be obviously just 1 plus 9 plus 4 plus 2, which is equal to 16. So that means that number 25, the answer is A. The first four rows of a table with columns V, W, X, Y, and Z are shown. For each row, whenever an integer n appears in column V, column W contains the integer 2n plus 1. Column X contains 3n plus 1, Y contains 5n plus 1, and Z 7n plus 1. For every row after the first, the number in column V is the smallest positive integer that does not yet appear in any previous row. The integer 2731 appears in column W. The complete list of columns in which 2731 appears is. Alright, so the first thing I'm going to do is extrapolate this a little bit. I'm going to extend this and see what happens. Alright, so let's get the hang of this. Let's see what's happening here. So, as they explained, when you're going from V to W, you basically are doing a 2n plus 1. And then when you're going from V to X, you're doing a 3n plus 1. Right? And then from V to Y is 5n plus 1. And finally from V to Z is a 7n plus 1. So basically, if you write it out, it would just be as follows. N would be here, and then this would be 2n plus 1, 3n plus 1, 5n plus 1, and 7n plus 1, like that. So based on that, let's figure out a few more lines, not too many, just about 3 or 4 more lines. Now, the key thing is here. What do I put there? As they explained, every row after the first, the number in column V is the smallest positive integer that does not appear yet in any previous row. So 11 seems to be the natural next choice, but 11 already appears there, so I can't put 11. 12 is the smallest, because 12 does not appear yet. And now to get all the other ones here, 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 and here, I just now take 12 to be my n, and then figure out 2n plus 1, 3n plus 1, and so on. And when I do that, I get 25, 37, 61, and 85. So what's the next one? Well, the next one is 13, because 13 doesn't appear anywhere in this row, this row, this row, and so on, right? And figuring out the other ones is easy. It's just 2n plus 1, 3n plus 1, and so on. So this will be 27. This will be, that will be, 27, 40, 66, and 92. Next one is 14, because 14 doesn't appear yet. 29, 43, 71, 99. Next one, 15, but no, because 15 appears there. It can't go in V if it's already appeared before. But 16 can go there. 16 hasn't arrived anywhere yet. So 33, 49, 81, and 113. Okay, so that's I think that's good enough. I don't need to keep going. I just wanted to illustrate how this works. Okay, so now we get into this whole 2731 business. They're saying it appears in column W. Okay, so somewhere 2731 appears in this column. All right, so if it does, that means I can easily figure out what is n. N, well, 2n plus 1 is equal to 2731, right? So that means 2n is 2730, and therefore n is equal to 1365. Okay, 1365 goes there. All right, so that is pretty much, all we can do with that one. Now they're asking us, where else does 2731 appear? Does it appear here, here, or here? Does it appear in X, Y, or Z? All right, let's see. Well, if 2731 appeared in Z, that would mean that 7n plus 1 is 2731. And if that's the case, then n would be equal to 390. If 2731 appeared in Y, then that would mean that 5n plus 1 is equal to 2731, and therefore n would be equal to 546. If 2731 appears in X, then that means that 3n plus 1 is equal to 2731, and therefore n is equal to 910. Okay, so let's see here. We have to figure out if this is possible. You might initially think, well, it seems like, 390, 546, it seems like it's going to appear in all of them, so the answer is B. But that's not necessarily true. It's only true if these actually appear in V. So if 910 actually does appear there, I'm just going to write it in there for now, but I've got to prove that it appears there. 546 and 390. And the reason I have to prove that these actually do appear in V or not is because if they appeared somewhere else, let's say 390 appeared here, then it cannot appear here. As the rule states right here, for every row after the first, the number in column V is the smallest positive integer that does not yet appear in the previous row. If it has already appeared, if that number has already appeared somewhere in previous rows, it can never appear in a column V after that row. Okay, so here we go. Let's just start with the 390. So I've got to show whether or not this 390 appears in any of these rows. So does 390 appear in W? If it does, it would be of the form 2n plus 1. If 390 appears in the other row, it would be of the form 3n plus 1. If it appears in y, it would be of the form 5n plus 1. And if it appeared in z somewhere, it would be 7n plus 1. When you solve for these, you get n is equal to 194.5. This gives you 129.6. This gives you n is equal to 77.8. This gives you 55.5. So what that means is that since these are not integers, this 390 is never going to appear in w, x, y, or z, because it's never of any of these forms, because n has to be an integer, and none of these n's are integers. So that means that 390 does indeed appear here. So that is exactly what we needed. And since 390 appears there, the 7n plus 1 form of it is 2731. So 2731 does indeed appear in z. So we can eliminate this as one of the answer choices, because we've proven that it appears in z, and we were already told that it appears in w. All right, so I hope you get the hang of this. So now we got to move forward to 546, this guy right here. Same sort of story, same sort of scenario. Okay, so 546. If 546 is to appear in column V, what that means is that it can never have appeared anywhere in W, X, Y, or Z in any of the previous rows. So that means we have to figure out if 546 appeared earlier, yes or no. Okay, so first thing we need to do is figure out whether or not these can give integer values, yes or no. So equate these. 546 is equal to all of these, 7n plus 1. So if I do the math here, n is equal to 272.5. This gives me n is equal to 181.6. This gives me n is equal to 109, exactly, an integer, great. And this is 77.85. Okay, so all of these didn't work except this one right here. Okay, so 109 is sort of my potential. I'm not sure though if 109 will appear, but it could. If 109 appears there, then the 5n plus 1 would be 546. But if 546 appears there, then it can't appear here. So I've got to retrace my steps. I've got to first concentrate on if 109 appears there or not. So we got a little bit of double work now. Okay, so let's go through this. We have to now do the same thing for 109. Does it equal 2n plus 1 and so on? 3n plus 1, 109, 5n plus 1, 109, 7n plus 1. Okay, for each of these we get the following. N here is 54 exactly, n here is 36 exactly, n here is 21.6, and n here is 15.4 approximately. Okay, let's just concentrate on the 54. We'll put in both integers, 36 and 54. 54. Okay, well, we got to do the same thing with 54, so we got a lot of work here. 54, same thing. Well, you get the hang of it. I'm going to do pretty much the same thing there. Can it equal 2n plus 1, 3n plus 1, 5n plus 1, and 7n plus 1? And when I do that, I get values of n of 26.5, 17.6, 10.6, and 7.5. So since none of those are integers, that means that 54 cannot appear in W, X, Y, or Z, because the starting point has to be an integer, the starting point being n in column V. And since the starting point is not an integer, 54 can never appear in W, X, Y, or Z. So 54 can appear in column V. So I will put a check mark right here. So this is valid. If 54 can appear there, which it can, I've proven that, then that means the 2n plus 1 is 109. Right? And that means that 109 cannot appear here. Since 109 has already appeared there, it cannot appear later on. So that is not allowed. And since 109 cannot appear there, we will not get a 546 there. And since 546 cannot appear there, it can appear here. Right? And since 546 can appear there, when we do the 5n plus 1, it will end up creating a 2731 here. So it also appears in column Y. So I guess we can eliminate this one and this one. Now we just have to show, does it appear in X? Yes or no? The 2731. All right, so if it's going to appear in X, that's 3n plus 1. That means we've got to look at this guy here, 910. So we've got to concentrate on this guy now. If 910 appears in any of the others, then it cannot appear here. So let's see if it could appear in any of the other columns. So 910 would equal either 2n plus 1, or 910 would equal 3n plus 1, or it would equal 5n plus 1, or it would equal 7n plus 1. For each of these, when we solve for n, we get the following: 454.5, 303 exactly, an integer, 181.8, and 129.8 approximately. So the only one that gives an integer value is 303. All right, so let's concentrate on the 303. 303. Now, I'm not sure if it will appear in V or not, but let's see. If it appears in V, that means it does not appear anywhere previously. So we have to see 303, can it equal 2n plus 1, and so on. 3n plus 1, 5n plus 1, 7n plus 1. All right, so for each of these we solve, and let's see what we get. For the first one, we get exactly 151. And then the next one we get 100.6. The next one is 60.4. And the next one is 43.1. All right, so we get another integer value, 151. Okay. So I've got to figure out if 151 can appear there. So I got to go through this whole thing again. All right, by this point you become an expert, so you don't need me to talk you through it anymore. We got to again equate these 4 to 151, and when I do, I get the following values for n. I get 75 exactly, I get 50 exactly, I get 30 exactly, and I get 21.4. So any one of these will be sufficient to prove whether or not 151 can go there or not. So let's just try 30. Well, 30, I think I'm confident that it will appear there, but let's just be 100% sure by equating them to these 4. When you do, you get n is equal to 14.5, 9.6, 5.8, and 4.1, all approximate. So that means that 30 cannot appear in w, x, y, or z because the starting point has to be an integer, and none of these are integers. So 30 can appear here in column V. If 30 appears in column V, then the 5n plus 1 will be 151. So since 151 appears there, so now let's talk about this carefully. 30 can appear here, as I have shown. If 30 can appear there, the 151 can appear there in the y column. If 151 appears there, it cannot therefore appear there, right? Because it's already appeared before, therefore that number cannot go in V later on. If 151 cannot appear in the V, then that means that when you take the 2n plus 1 of it and made 303, the 303 will never happen there because 151 couldn't be placed there, so you're not going to get that 303 there. So since 303 cannot go there, it can go here. It can eventually end up in the V column. If 303 ends up in the V column, then the 3n plus 1 will be a 910, which is right here. And since the 910 does indeed appear there, it cannot, therefore, appear here in the V column, since it's already been there. And therefore, if you were to do the 3n plus 1 and try to make it into 2731, there's no way it would go there. Since 910 does not appear there, the 2731 would not appear there. So that shows that it does not appear in X. So this is out, B is out, and therefore by thorough process, we have proven that the 2731 can only appear in W as they have stated in the question. We proved that it appeared in Z, and we proved that it appeared in Y, and it does not appear in X. So it appears only in W, Y, and Z, therefore number 25, the answer is D. A 0 or 1 is to be placed in each of the 9 1x1 squares in the 3x3 grid shown so that each row contains at least 1 0 and at least 1 1. And each column contains at least 1 0 and at least 1 1. The number of ways which this can be done is. All right. Well, what are my combinations? If I look at any particular row, I can have either 0 and 1 with some other number, because I've got to have at least 1 0 and at least 1 1. This guy can be anything. It could be a 0 or a 1. So let's make our combinations 0 1 0, 0 1 1. And also, I believe if we were to be consistent, 1 0 0, 0 0 1, 1 0 1, 1 1 0. So these are the 6 possible ways that we can put the numbers in the rows or the columns. So you say, okay, well, that's fine. So I've got 6 ways to put these numbers here, 6 ways here, and 6 ways here. So the total must be 6 times 6 times 6, which is 216. But 216 is not one of the answer choices. All the answer choices are less than 216. What that means is that some of these 216 configurations are not valid, meaning they don't meet the criteria. And there's a very simple one that I can illustrate. Let's say I put this one in all the rows. 1 0, 1, 0, 0, 1, 0, 0, 1, 0. The rows seem fine, but look at the columns. That column has all zeros. It doesn't fit the criteria. Each column contains at least one 0 and at least one 1. This column has all 3 zeros. Similarly, this column has all 3 1s. So this configuration is not valid. So we'd have to subtract that from the 216. So that's what we have to do. Now, it's obviously very time consuming, so the hope is that we can get a pattern sooner rather than later. So here we go. So to figure this out, what I'm going to do is erase the bottom row. Just concentrate on the first two. And for the first 2 rows, I will place what I can with my answer, with my choices right here. There's 6, right? So for example, I can put 1, 0, 1, and that can be my first row. And then for my second row, I can choose any of the other guys. So I can put 0, 1, 0, 1, 0, 0, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0. Okay, so far everything is valid. Now what I have to do is select what goes in my third row from these 6. Some of these will be valid, some of them won't. And that's the key. So what I'll do is I'll walk you through the first few, and then I'll just start churning out the numbers. So for example, this third row, what do I put? I can't put something that has a 0 here or a 0 here, because that would be invalid. I also cannot put something that has a 1 there. So there's only one of these that fits. That is the one that is 1, 0, 1. This one right here. 1, 0, 1. That's the only one that would make the configuration match the criteria of the question stem. So I put a 1 there because there is only one. All the other ones, if you try them, they would fail the criteria. All right, the next one. This one, again, I can't put a 0 here, so I got to eliminate this one, and this one. But the other ones are valid. This one, and this one, fine. So 3 of those. So put 3 here. See what's happening here? So again, let's do a couple more. For this next one, I can't put a 0 here, right here. Because if I did, that would make a column with all 3 zeros, and that's not valid. So this one's gone, this one's gone. Oops, sorry. This one's gone, and this one's gone. But the other 3 are valid. So I've got 3 choices for that one. The next one, I cannot put a 0 here. I cannot put a 1 here. So any one that has a 0 as the first one and a 1 as the second one is not good. But the other 2, these are valid for that one. So I've got 2 that I can place there. Then this one, interestingly, all of them are valid, because I've already fulfilled my criteria of at least 1, 0 and at least 1, 1 for each of those columns. So the third entry of the column can be anything. So all 6 are valid. This one, can't put a 0 here, can't put a 1 here. So this one's no good, this one's no good, that one, that one. So there's 2 that are valid. All right, so I hope that makes sense. Now I got to add them all up. 1 plus 3 plus 3, 7, 9, 9, 15, 17. So this gives me 17 here. I'll put it up here. All right, so then what you do is you do it for the next one. And there's going to be, this was one such scenario. There's this 1, 2, 3, 4, 5, 6 scenarios, right? There's 36 in total. Correct? Because you got 6 choices here, 6 choices here. 6 times 6 is 36. Now 36, quite a bit of work, but the good news is that there's a pattern. So let me just go to the next one really quickly. 1, 0, 0. Now we got to figure out all the ones for 1, 0, 0. Okay, let's fill in the other guys. So 1, 0, 1, same as the top row. 0, 1, 1, 1, 0, 1, 1, 1, 0. Okay, and I'm not going to walk you through it because you're an expert now. I'm just going to write down the number of possible choices from these 6 that make this valid. 3, 1, 3, 6, all 6 for this one, 2, and 2. And when you add these up, let's see, we got 3, 4, 7, 13, 17. There you go. So the good news is that every time you do this, it's 17. And so you'd have 6 like I did, then you'd have another 6, then you'd have another 6, another 6, another 6, another 6, right? Because these were 6 that I did. Each of these give you 17, like that. So the total would be 6 times 17, and that is 102. So number 25, the answer is D. Sam thinks of a 5-digit number. Sam's friend Sally tries to guess his number. Sam writes the number of the matching digits beside each of Sally's guesses. A digit is considered matching when it is in the correct digit in the correct position. What is the sum of all possible values for Sam's number? All right, so we've got to do some analyzation here. Okay, so let's start. Let's see what we can get. Well, the first thing that caught my attention is this one right here. That 0. So that means 7 is not going to be in the first digit, 1 is not the second digit, and so on. And then when I looked at this one, it looked very similar. Now, 7 is not the first digit, according to this guy, so it can't be the first digit here. According to this guy, 1 is not the second digit, so therefore 1 is not the second digit there. 7 is not the third, 7 can't be the third. 9 is not the fourth, so therefore 4 perhaps is the fourth. 4 is not the fifth, 4 is not the fifth. So when you look at those two, that means that 4 must be the fourth digit. Because, just to repeat, none of these are correct. And therefore, 7 is not correct, 1 is not correct, 7 is not correct, and the last 4 is not correct. The only one, by process of elimination, that must be correct is that 4. So that one, when you look at those two, it helps you conclude that the fourth digit must be a 4. So we're done looking at that one, we're done looking at this one. Okay, now let's look at all the other ones. So the first one is 515405. So 5, 1, 5, and then 5. I won't write the 4 because 4 has already been established. And the number of matching digits is 2, but since the 4 we know matches, I have to now figure out which one of the remaining of these 4 is the other matching digit. That's why I put a 1 there. Okay, the next number is 21531. So 2, 1, 5, 3. I'm going to skip that and just put the 1 because the fourth number is 4 for sure. And one of those matches. Okay, the next one, this one we don't need to do because that has already been established. None of those are right. Then we've got 5, 9, 1. Skip the fourth one, and 5. Only one of those matches. And then the next one, 5, 8, 3, 4, 2. Only one of those matches. And finally 3, 7, 3. Skip the next one is 8. There you go, only one of those matches. Okay, now let's discuss this. So now I've got to look at this and try to figure this out. Well, we established that the fourth number is a 4. Okay, now let's look at this guy. I'm going to start by saying the first number is a 5. We got to start somewhere. So I'm going to establish that. I'm going to say the first number is a 5. That means the one correct is this guy. Now the next number, it cannot be a 1 according to this one, remember? None of those are right, and it has 1 in its second position. So the next cannot be a 1. So I'm going to put that here, not 1. And then if this is the only one that's correct, then that means this is incorrect, this is incorrect. So the third one is not a 5, and the fifth one is also not a 5. in this scenario where I have chosen 5 to be the first digit. Okay, let's go to the next one. Only one of these is correct. Okay, well, the first one has already been established as a 5, so that means this cannot be a 2. Okay, well, this one we know it's not a 1 because that was right there. If you remember right here, 1 cannot be the second digit. And then, so that takes care of that. 5, well, the third digit is not a 5, so that's wrong. And then 1 for the fifth digit, that's the only other option. That's the only option that works for there to be one of these correct. So that must be the fifth one. Okay, we've established that as a 1. Great. Let's keep going. This next one, 5 is the first digit. Okay, that works. That's what we have, actually. 9, well, only one of these can be correct. So that means that the second one cannot be a 9. And then, therefore, the third one cannot be a 1 because only one of those can be correct. And the fifth one, well, we already know that the fifth one is a 1. All right, great. Now let's go to this one. 5, yeah, 5 is the correct one, so that's great. So that means the second digit cannot be an 8. The third digit cannot be a 3. And then the other two have already been established. And then the last one, the first one, is definitely not a 3. That's already been established to be a 5. And let's see here. The second digit could be a 7. I'll just put that there for now. The third digit, it can't be a 3. So this is gone. And then the last digit, well, that's already been established that it's a 1. So obviously it's not an 8. All right. So that means it has to be a 7. That's the only way that's going to work. Okay. So we've established a pretty decent amount of work here. The only thing we didn't get was the middle one. So the middle one obviously looks like it could be anything except it cannot be a 5, a 1, or a 3. So let's write out all these numbers. These numbers will be 5, 7, 4, 1. And the middle digit is going to be either a 0, a 2, a 4, 6, 7, 8, or 9. The only thing it cannot be is 1, 3, or 5. But the rest of the digits are the same. So I hope you understood how I was able to figure that out. I tried to explain it in a way that is digestible. So these are the numbers. Okay, let's add them up because we have to figure out the sum. And that sum is 402,887. Now, is that one of the answer choices? No. It's less than the answer choices. So that obviously means that we have to discover more. Now, before I go on and discover more, I want to double check if any of these actually, if all of these work. And when you go through these, you can easily double check. But there's one that falls apart that has to be disqualified. And it's one that has a 7 in the third position, because this is a very important one. None of these can be true. You cannot have a 7 in the first position, 1 in the second position, a 7 in the third position, a 9 in the fourth position, or a 4 in the fifth position. So if you look at these numbers that I just wrote down here, one of these falls apart, and that is this one right here. This one right here, 5, 7, 7, 4, 1. It has a 7 in the third position, and that is not allowed. So that one I will subtract. And when I subtract that, 5, 7, 7, 4, 1, my new total is 3, 4, 5, 1, 4, 6. All right. Let's move forward now. Let's go to another scenario. So we're going to proceed in pretty much the same way. We have already established that 4 must be that fourth digit. So now, just as before, we're going to go and see what we get for everything else. Just how we did over here. So we've got 5. Remember, the second digit cannot be a 1 according to this guy right there, so I'm just going to skip over that. 5 and 5, and only one of those is correct. Then from the next one, very similar to I did over there, 2, 5, and 1, only one of those is correct. Then 5, 9, 1, 5, only one of those is correct. And then 5, 8, 3, 2, one of those is correct. And finally, 3, 7, 3, and 8, only one of those is correct. Okay, let's work with this. 1, 2, 3, 4, 5, and the fourth one is a 4. Now, if you recall, in the previous one, I had set that to be the true value for the first digit. Now I'm going to select this one to be my one that is correct, because remember, 1 is correct. So that means this guy cannot be a 5, and this guy cannot be a 5. All right, so we got that taken care of. Now let's look at the next line. 2. Can 2 be the first digit? Perhaps, but 5 has already been selected as being the correct third digit. So that means this cannot be a 2. So that's the only way this can work. And therefore this cannot be a 1. All right. Now next one. Only one of these is correct. Let's see which one. Can't be this because this one cannot be a 5. Can't be this because that one cannot be a 5. We've already established that. The third digit has already been established as a 5, so it's obviously not a 1. So by process of elimination, this must be a 9. Okay, next one. Only one of these is correct. Let's see which one. It can't be this one because that cannot be a 5. Well, it's not an 8 because that's already been established as a 9, so that one's gone. This one is wrong because it's already been established as a 5, and therefore by process of elimination, that must be a 2. And then let's look at the last one. I guess that's just a 3. That's the only way this is going to work. And obviously this is not going to be a 7, this is not going to be a 3, and this is not going to be an 8. So we got all of them this time. So we got a number 3, 9, 5, 4, 2. Great. So 3, 9, 5, 4, 2, when you add it to 3, 4, 5, 1, 4, 6, it still falls short of the answer choices. So that basically means I got to keep going. I've got to make a few more. All right, let's try to make a few more. So in the same style, we are going to do the same thing again. We have established that 4 is the fourth term, and we have to now do the same analysis as before. Only one of these is correct. 2, 5, 1, only one of those is correct. 5, 9, 1, 5, only one of those is correct. And 5, 8, 3, 2, only one of those correct. And finally 3, 7, 3, 8, only one of those is correct. Now if you recall, for the first one I had set this guy to be correct. For the second example I had set this guy to be correct. So obviously for this one I have to set the third 5 to be correct. So there we go. I put that as my choice. So that means that obviously if I were to write this number out like this is a 4, this is a 5, and therefore this cannot be a 5, and this cannot be a 5, since only one of these is correct. Okay, let's keep going. Next line, 2, 5, 1. Well, the last 5 has already been assigned, so it's obviously not a 1. This one, we've already established it cannot be a 5 for the middle number, so by process of elimination, that must be a 2. So we've assigned that now. Next one, 5, 9, 1, 5. Well, this is obviously not a 5. This perhaps could be a 9. Let's just put that in for now. I'm not sure if it is. Maybe, maybe not. This perhaps could be a 1. Oh, there we go. This is a 5, and this is a 5. So that means this is the one that's right. and therefore this is not a 9, and therefore this is not a 1. All right, let's go to the next one. Only one of these is correct. Which one? Not a 5. It's not this one. This one has already been established as a 5, so it's not that. So it's not a 2. So we got an 8 or a 3. Okay, so 8 or 3. And then the last one, only one of these is true. Well, obviously it's not this one because we've already established that to be a 2, so not 3. It's not the last one because that's already been established as a 5. And then we've got either 7 or 3. 7 or 3. Well, the only way this can work is if this third digit is a 3, and therefore that second digit is open to be several choices, but the only thing it cannot be is it cannot be a 7 or an 8. So there we go. We got some more. So let's write out these numbers: 2, 3, 4, 5. And the second digit can be anything except 7, 8, or 9. So it can be 0, 1, 2, 3, 4, 5, 6. And of course, all the other digits are the same. All right, let's do our test now. Let's see if any of those get disqualified or not. Remember, you cannot have this 7 in the first position and so on. And if we look at that one, there's one that gets disqualified, and that is when you have 1 in the second position. That is not allowed. So that would be this one right here. You can't have this one because that one has 1 in the second position. So I'm going to just add up the other guys. And that total is 142070. All right, so I think we've got it. We have this one, 3, 4, 5, 1, 4, 6. We had this one over here. Don't forget this guy, this 39542. 39542. And then, of course, we just got this one, this 142070. And then when you add up all these guys, the grand total is 526758. 526758 is this choice E for number 25. PJ starts with m equals 500 and chooses a positive integer between 1 and 499 inclusive. He applies the following algorithm to m and n. PJ sets r equal to the remainder when m is divided by n. If r equals 0, PJ sets s equal to 0. If r is greater than 0, PJ sets s equal to the remainder when n is divided by r. If s equals 0, PJ sets t equal to 0. If s is greater than 0, PJ sets t equal to the remainder when r is divided by s. For example, when n equals 8, PJ observes that r is 4, s is 0, t is 0. For how many of the positive integers n between 1 and 499 inclusive does PJ's algorithm give r between 1 and 15 inclusive and s between 2 and 9 inclusive and t equal to 0? Well, let's talk about this. Directly from the question, when r is divided by s, we are going to be given some integer and a remainder of t. And that comes directly from the question stem. Now, we are told that we want a scenario where t is 0. So this just reduces to r over s is equal to a, where a is some integer that's greater than 1. All right, so that means r is equal to as. So that takes care of at least one scenario. Now we move on to the next one. The next one says that s is equal to the remainder when n is divided by r. So when n is divided by r, we have some integer b plus the remainder, which is s. So that means n is equal to b times r plus s. And this is important, so I'll just put a star because we're going to use it later. Now in this formula, I actually know the value for r, well, at least in terms of a and s, so I'll substitute it in. So b times r, but r is as plus s. And now I can factor out an s, and I get ab plus 1. So that basically means that n looks like it's some multiple of s. So this, I'll just let it equal c. So n is equal to cs. And that's an important fact, so I'm going to underline it. Okay, now let's move right along. We have to look at that one, that r is equal to the remainder when m is divided by n. So when m is divided by n, we have it equal to some integer, let's say it's d, plus the remainder, which is r. So that means mathematically that m is equal to nd plus r. And that is also an important finding, so I'll put a little asterisk there since we're going to need it later. And then now m is equal to nd plus r, but r is as, so I'll put that there. And then n is cs, so let's put that there, csd plus as, and then of course we can factor out an s. And when we do, we get cd plus a. And then this cd plus a, I'll just call it e. Therefore, m is equal to es. And that just tells me that one is a multiple of the other. All right, so here's our initial findings, and I hope there was nothing too complicated about that. All right. Now let's talk about what it is that they want us to do. Well, some of these things they have defined already, that m is 500 and that s has to be between 2 and 9. And they want us to figure out values of n. Okay. Well, let's start with this, since that includes m and s. So that means 500 is equal to es. And therefore 500 divided by s has to equal some integer, where e is some integer, right? So therefore, in this range, the only way that that's going to be an integer is if s is equal to 2, 4, or 5. Those are the only numbers that divide evenly into 500. Okay, so that's pretty good progress. We've narrowed it down to just 3 numbers, for s, that is. So now let's look at the next criteria. The next criteria that they give us is that they want r to be between 1 and 15. Okay, well, we know that r is equal to as. So r is equal to as, and therefore r over s is equal to a, where a is some integer greater than 1. Okay, so let's figure out, since we know s and we have a range for r, let's try to figure out the values for r. When s is equal to 2, it looks like r could be either 4, 6, 8, 10, 12, or 14 within this range. When s is equal to 4, the only way I could make this work is if r is equal to either 8 or 12. And when s is equal to 5, I think r can only be either 10 or 15. All right, so we've got a finite number. These are s, these are my values for r, and I think I can figure out n, the values for n. So now what we have to do is we have to create a table. And that table is as follows. Put s here, put r here, and then we'll put 500 minus r here. Then we have the divisors of 500 minus r. Don't worry, I'll explain all of this. And then our possible values for n. Okay, so we have to, first of all, fulfill the criteria. And the criteria is as follows. The first criteria is going to be that n is a divisor of 500 minus r. So let me explain that, and I'll just start with an example. Simple example, let's just make it the first one. So when s is 5, we'll start off with s equals 5. When s is 5, r can be either 10 or 15. So these are my values when I'm filling in the table. Now notice we have an equation that I had put a star beside, and that equation is right here, that m is equal to nd plus r. M is equal to nd plus r, so m is equal to nd plus r. Now let's use these values. Let's just start with the first one. So m is set as 500, that's fixed, and then n we don't know, and therefore the d we don't know, but r in this case is 10. So we have 10. So if we were to put it on the other side, it would basically be 500 minus r is nd, and therefore 500 minus r divided by n is equal to d, where d is an integer. So that tells me that n has to be a divisor of 500 minus r. So that's why we put these guys in here, in case you were wondering, where did that come from? All right. So that's rule number 1. So we'll put that there, rule number 1. Rule number 2 is that n is equal to cs, right? Right here. So that means n is a multiple of s. So n is equal to cs. N is a multiple of s. Rule number 3. Rule number 3 is that n has to be greater than r. And because, you know, you're taking remainders. See, r is equal to the remainder when m is divided by n. So the remainder obviously has to be less than n. So n has to be greater than r. So that's rule number 3. And rule number 4, the last one, is taking into consideration this one that I put the star, that n is equal to br plus s. Okay, well, what rule does that give us? N is equal to br plus s. That means that when n is divided by r, you get b plus a remainder of s. That's basically what that means. All right, so let's fill out a few. I won't fill out all of them. I'll fill out a few. 5r, 500 minus r, well, that's going to be just 490. Now the divisors of 500 minus r, divisors of 490, look like 5, 10, 35, 70, 245, and 490. Now we have to figure out our n. Okay, so let's go through these rules here. N is a divisor of 500, the first rule. Okay, so that means n is going to be any one of these. Those are the 6 possible choices. N is a multiple of s. Which one of these is a multiple of s? I think all of them are. All of them are a multiple of 5. Okay, so that keeps all 6 in contention. N is greater than r. N is greater than r. Okay, so all of these we have to compare with r. The only ones that are greater than r are these 4. So that means these 2 are gone. And then the last criteria, when n is divided by r, the remainder is s. So if these are our possible n's, when we divide by r, the remainder has to be 5. And it looks like The only one that fits that fourth criteria is 35 and 245. So there we go. Those are the two possible values of n. So let's do the same thing now with 5 and 15. 500 minus r would be 485. The divisors of 500 minus r are just 5 and 485. And in particular, I'm only listing numbers in this section or that column that are multiples of s. So I just immediately just put in only multiples of s. Otherwise, there'd be so many to list. It would make it very time consuming. So which ones are a multiple of s? Well, both of them. So those two obviously are in contention. Now we have to fulfill the third criteria, which is n greater than r. Only one is left. And then the last one, where n divided by r gives a remainder of s. This divided by r would indeed give a remainder of s, which is 5 in this case. So 485. All right. So now we plug in all the other ones. When s was 4, r was 8. When s was 4, r was 12, and so on, right? If you remember, we had these guys when s is 4, r is 8 or 12. And you do the same thing. So this would be 492, and then here you get 4, 12, 164, and 492. And then of those, when you go through these four criteria, the ones that would work are 12, 164, and 492. And I'll just do one more. For 412, it would be 488 for 500 minus r. The divisors of 500 minus r are 4, 8, 244, and 488. And if you go through these four criteria, the only one is 244 that comes out. And that's what you do. Then, of course, you have to do that same thing for these guys. And when you do, you get this very nice table. And there you go. As you can see, it has all the findings. I had done the first 4 there. This table includes all the remaining ones. And these are the values of r. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 possible values of n, I should say. So that means that this very challenging question, very time-consuming question, number 25, the answer is 13, which is choice E. P and also W is on PV. U is on PS and T is on PQ, and Q is on Q and ST passing through W for some real number X. If the areas of PUW are 4x plus 4, SUW is 2x plus 20, SVW is 5x plus 20, SVR is 5x plus 11, QVR is 8x plus 32, and QVW is 8x plus 50. What is the area of PTW? Before I begin this question, I'd like to give a little bit of a primer to illustrate some very important fact. And once you have that fact, it will make a lot more sense as to what the question is all about. So let's say we have a triangle, and that triangle has a base, and that base is in some ratio. It doesn't really matter, but let's just say it's in some ratio. We'll call this A, we'll call this B, and we'll call this C. Now I said to you, figure out what is the ratio of the area of this to the area of that. Okay. The first thing I need to do is draw an altitude. So I'll draw an altitude that's perpendicular to the base. And we'll call that height. So the area of AB, and we'll call this D, I guess, ABD, over the area of BCD. First, let's do it the long way, 1/2 base times height. So the top would be 1/2 base, which is AB, times height. The bottom is 1/2 base, which is BC, times height. It has the same height. And if you notice, the heights and the halves cancel, so you just have AB over BC. So in any kind of situation like that, all we really need to do to figure out the ratio of the areas of the triangles is look at the ratio of the bases, AB over BC. And that's it. If we're told the ratios, like if I was told that this AB is equal to 2 and this BC is equal to 1, then it becomes even easier, 2 over 1. So that is the primer I wanted you to learn about. So now let's tackle this guy, and of course I'm going to blow it up a little bit. Alright, here we go. Let's put it in the diagram, 4x plus 4. So 4x plus 4. And then 2x plus 20 is this guy here, 2x plus 20. And then 5x plus 20 is this guy, 5x plus 20. And then 5x plus 11 goes here. And then 8x plus 32 is here. And then there's one more, right? 8x plus 50. Okay, we're not told anything about that. We're not told anything about that. So I'll just call them something. I'll call this one M and I'll call this one N. So this question is essentially telling me to find PTW, which would be find N. This is my task in the question. All right, here we go. And just like the primer, this triangle over that triangle is equivalent to the bases, QV over VS. So when you add it up, what do we get? Well, before I even include M and N, I think it's just easier to just include these ones since we already have. So I'll just do it with that. So QVW over this 5x plus 20, which is SVW, is going to be the same as QV over VS, right? Just like the primer. So QVW over SVW is the same as QV over VS. But QV over VS is also applicable to these guys down here. They're just upside down. And those triangles are QVR and 5x plus 11, which is represented as SVR, right? Okay, so now we can use this and this to make an equation. So that will be 8x plus 50 over 5x plus 20 is equal to QVR, which is 8x plus 32 over SVR, which is 5x plus 11. And then cross multiply, and when we do, we get 40x squared plus 88x plus 550x plus 250x plus 550. And then the other side is going to be 40x squared plus 160x plus 160x plus 640. And when you do that math, you get 338x plus 550 is equal to 320x plus 640. So that means 18x is equal to 90, and therefore x is equal to 5. Great, x is equal to 5. So now all of these we can figure out in terms of numerical values. This is going to be 24. This is going to be 30. This is 45. This is 36. This is 72. And this is 90. Great. Okay. So far so good. Now let's move on to the next thing, which is involving the M's and N's. All right. Well, I think it would be very helpful if I actually knew some numbers. If I knew some numbers, that would really help me out. But do I? And the answer is sure. Why not? QV over VS, we can easily get a number for it. It would be 90 over 45, right? We already have the equation. QVW, we just figured out, was 90. And SVW, we just figured out was 45. So QV over VS looks like 2 to 1. There we go. This is 2 and this is 1. So I'll just write that here, QV over VS. So that's a very important finding. And now we can use that to figure out some very important details. So that basically means that this triangle over this triangle would be 2 to 1 in its ratio because it's equal to QVS. So PQV, that big one, over PVS is the same as QV over VS, which is 2 to 1. So PVQ, it looks like M plus N plus 90. And then PVS is 24 plus 30 plus 45, and that's 2 to 1. All right, that's pretty good finding. And that looks like M plus N plus 90 is going to be, if I cross multiply, 24 plus 30 plus 45 is 99, times 2 would be 198. So that means M is going to be equal to 108 minus N. All right, great. And I think we have just one more step to go and we'll get this. And that final step, I think, is to just look at the ratio. But in a slightly different way. We're looking at it from that angle being the base, that this is the base now. This over that is the equivalent of QT over PT. But we can also write this over that is QT over PT. So I think all I need to do is just use this fact in that diagram. So M is equal to 108 minus N, and this diagram should be sufficient. So M is equal to 108 minus N. Okay, now let's figure this out. M over N is the same as the bases QT over TP. But I can also use the big triangles, which would be TSQ over PST. And there you go. That should be enough for us to figure out M and N. And our goal is, of course, to figure out N. Okay, here we go. So since I'm interested in just in N, I'm going to use M is equal to 108 minus N over N. And then this part here, I can just get from the diagram TSQ, that's going to be M plus 90 plus 45. And PST from the diagram is N plus 24 plus 30. Okay, so 108 minus N over N, and the M, of course, I'm just going to substitute that 108 minus N plus 135, and this is N plus 54. All right, cross multiply now. And when I do, I get 108 minus N times N plus 54. And this is N times 243 minus N. And then this will become 108N plus 5832 minus N squared minus 54N. On the other side, 243N minus N squared. The N minus N squareds cancel, so that's great. I don't have to worry about any quadratic. And if I collect like terms, I'll get 189N. And then finally, N is 5832 divided by 189. When you do that, you get about 30.8. All right, 30.8. That was what I used to represent PTW, and therefore its value is 30.8, and that is closest to 31. Number 25, the answer is E. We call the pair Mn of positive integers a happy pair if the greatest common divisor of M and N is a perfect square. For example, 20 and 24 is a happy pair because the greatest common divisor of 20 and 24 is 4. Suppose that k is a positive integer such that 205,800 and 35k is a happy pair. The number of possible values of k with k less than or equal to 2940 is. Before we begin, let's do a little bit of a primer about GCD, greatest common divisor. So the motto of this question will be think minimum. And it will be clear later in the question as to why this is the motto. So let me explain. Let's say I give you two numbers and I said find the GCD. But I'm going to make them some big numbers. The very first thing you want to do is break them up into its prime factors. So for example, this is not broken up into its prime factors. So eventually we will need to do that. But let's just give an example, something different. So 2 to the power of 7, 3 to the power of 2, 5 to the power of 4, 7 to the power of 1. And we'll stick in another one, 11 to the power of 3. And then I've got to create another number, right? So 3 to the power of 5, 5 to the power of 1, 7 to the power of 4, 11 to the power of 2, and I'll put in another 13 to the power of 1. And I said find the GCD. How do you do that? Well, the GCD will be equal to as follows. For 2, it will be the minimum of the powers of 2 from each of these. So here it's 7. Here there is no 2. You notice there's no 2 to the power of something. So that means it's really 2 to the power of 0. So that's basically what you put there. Then it would be 3 to the power of the minimum of the powers. So 2 here and 5 there. So 2 and 5. And then next one, 5 to the power of the minimum of 4 and 1. So 4 and 1. And you're getting the hang of this, hopefully. And then keep multiplying. So the next one will be 7 minimum, 1 and 4, right? Next one, 11 the minimum, and those exponents are 3 and 2 this time. And then finally 13 and the minimum. Well, here there is no 13. So it's really 0 there, but there's a 1 over here. Okay, let's figure this out. So what is the minimum of 7 and 0? Between those two numbers, which one is the minimum? Well, obviously 0. 3, minimum of 2 and 5 is 2. Minimum of 4 and 1 is 1. Minimum of 1 and 4 is 1. Minimum of 3 and 2 is 2. Minimum of 13 and 0 is obviously 0. So these ones just become 1s, so those are gone. So all you're left with is 3 to the power of 2, 5 to the power of 1, 7 to the power of 1, 11 to the power of 2. This is the GCD of this guy. So that is why the motto for this question is think minimum. And this is, in my opinion, the best way of understanding greatest common divisor. Okay, now that you are an expert, we will begin the question. We are given this, okay? 205, 800, and 35k. I have to break those up into their prime factors. So that will become 205,800. Get out your calculator. You can do this anywhere you want. It's 2 to the power of 3, 3 to the power of 1, 5 to the power of 2, and 7 to the power of 3. Okay, 35, I should say. 35k, well, that's obviously 5 to the power of 1, 7 to the power of 1, and then some k, and I don't know what k is. Okay, now, the only thing I'm told is k is less than 2940. All right, I think that will come into play later on in the question. Now, how do I go about this? I don't know what k is, but that's okay. I do know what is this side. This side is very helpful. We've got 2s, we've got 3s, we've got 5s, 7s. So I don't know what k is, but I am confident that it probably, although not guaranteed, is going to have at least some of those prime factors. Okay, so I'll say it's 2 to the power of something, A, 3 to the power of something, B, 5 to the power of something, C, 7 to the power of something, D, and then maybe some other stuff. All right, it can also include some other numbers, but I will talk a little bit about that later. But let's just make it simple for now. Let's just say the k is something like that. Now, if there is an additional factor, like let's say there was an 11 to the power of e, it really wouldn't change our GCD, because here there is no 11. Here the 11 is 0. So just like in the primer, the minimum of 0 and e is 0. So the GCD wouldn't change no matter what you tag on to that k. The only thing we have to worry about later on in the question is ensuring that k is less than 2940. Okay, so let's keep it simple for now. Let's just say that's k. Some power of 2, 3, 5, and 7. All right. Now we have to figure out the GCD. So just as before, the GCD will be 2 to the power of the minimum of 3 and a. 3 to the power of the minimum of 1 and b. 5 to the power of the minimum of, oh, here you have to be careful. This one's easy too, but here it's not c. There's a 1 here, so we got to combine that. So it's 1 plus c, right? Because 5 to the power 1, 5 to the power c, you would have to combine those exponents, and it would become 5 to the power of 1 plus c. So that becomes 1 plus c. And then finally 7 to the power of the minimum of this 3, and again 1 plus d. So 1 plus d. Okay, so far we're doing great. Now we have to think about this. We want this GCD to be a perfect square. So how can this be a perfect square? The only way a number is a perfect square is if the exponents are even. So that is something that we have to concentrate on. The exponents have to be even. It's the only way a number can be a perfect square. So that means that 2, or we don't even need to care about the 2. We can just talk about min of 3 and a. That has to be an even. So what are my even numbers? What are my choices? Well, maybe 0 or 2 or 4. But it can't be 4, right? Because the minimum of 3 in some number can never be greater than 3. No matter what you put in here, the maximum that I can have here is 3. So there's no reason to put in that 4. So 0 and 2 are my only options. And that means a is either 0 or a is 2. Plug it in and you'll see that works out. Now let's turn our attention to this guy. Minimum of 1 and b. It's got to be an even number, so 0, 2. Can it be 2? No. Because again, same story. If this is a 1, the minimum of 1 and b can never be greater than 1, right? If you put a 5 in here, the minimum is always going to be 1. The only way it can be less than 1 if b is 0. So that means b is 0. It's the only choice for b. And then now we go to the next one here. The minimum of 2 and 1 plus c. What can that be? Well, our choices are 0 and 2 and 4, right? Even numbers. But you can't have a 0 because the only way to get a 0 is for this to be negative 1. And if that was negative 1, then k would no longer be an integer. Remember, this was k, right? If c is negative 1, we'd have a 5 in the denominator, and that's not going to make k an integer. So c can only be 1 in terms of the smallest value for c. If c is 1, then the minimum would be 2. And that's the only way we can make the minimum. But c could also be something bigger than 1. It wouldn't change the minimum. For example, if c was 2, this would be 2 and 3, and the minimum would still be 2. So c could have a few choices. I'm not sure how many, so I'll just put 1, 2, dot, dot, dot. We'll have to figure that out a little bit later. And then now, same story here. The minimum of 3 and 1 plus d. Well, remember, we have choices 0, 2, 4, like that. Can it be 0? Cannot be 0 because the only way that could be 0 is if d is negative 1. But we can't put d equals negative 1 because that would make k a non-integer. So d has to be at least, could be 0, but if it's 0, then the minimum would be 1. But we don't want 1 because 1 is not an even number. So 2, I think, is the only option. And that happens when d is equal to 1. And the minimum can never be 4 because the minimum cannot be greater than 3. All right, so these are our options. So we have boiled it down to this. So that means my A has 2 choices, 0 and 2. B is only 0, D is only 1, and C is what I have to kind of think about. All right, so here we go. Let's first talk about A equals 0, and then we'll talk about A equals 2. When A is 0, my K was 2 to the power of A, 3 to the power of B, 5 to the power of C, and 7 to the power of D, right? So when A is 0, it becomes 2 to the power of 0, 3 to the power of, well, B is always 0, 5 to the power of C, and 7 to the power of 1, because D is always 1. So this conveniently, very nicely actually, breaks down into just 5 to the power of C times 7. Okay, great. And recall that K has to be less than 2940. So 5 to the power of C times 7 has to be less than or equal to 2940. Divide through by 7, and that means you get 2940 divided by 7 is 420. So 5 to the power of C has to be less than 420. The only way that's possible is if C is 1, 2, or 3. If C is 4, it would become 625, and that is not less than or equal to 420. Okay, so we got some values for C when A is 0. Let's do the exact same thing for A is 2. When A is 2, my K becomes 2 to the power of 2, 3 to the power of 0, 5 to the power of C, 7 to the power of 1. So this is 4 times 5 to the power of C times 7, and that has got to be less than or equal to 2940, just like before. So divide both sides by 4 and 7, and when you do, you get 105. And therefore here, the only possible choices for C are 1 and 2. If C was 3, it'd be 125, and 125 is not less than 105. All right, great. I've basically done it. I've got pretty much all the values for each scenario. I've got, let's see here, when C is 1, K would be 5 to the power of 1 times 7, right? Because that's what K is, and that's 35. When C is 2, it would be 5 to the power of 2 times 7, which is 175. And when C is 3, it would be 5 to the power of 3 times 7, which is 875. All right, great. Over here, K is, this was K, right? Yeah, so 4 times 5 to the power of 1 times 7, and that is 140. And when C is 2, K would be 4 times 5 to the power of 2 times 7, and that is 700. So there we go. I got 1, 2, 3, 4, 5. 5 values for K. Or did I get 5? Yeah, I got 5. Okay, great. That should be the answer, right? Let's see. Oh, these are way more than 5. My answer is 5, but these numbers are so much more. So what did I miss? Well, it had to do something with the fact that K could have some extra prime factors attached to it. I touched on that a little bit earlier in the question, but I didn't want to bog you down too much. And that is why there's so many more than what I found. I found 5, but there's a lot more because they're tagging on extra primes. And if you tag on an extra prime, the GCD doesn't change because there is no 11 here. So the min, and I think I touched on this a little bit, the min of 0 and 1 is still 0. So when you tack on prime numbers to K, it wouldn't change the GCD. Now you say, well, then there must be infinite. No, because K has a restriction. It's got to be less than 2940. Okay, so now we got to figure this out. How many more? All right. So let's just look at these 5. 1, 2, 3, 4, 5, and figure them out one at a time. I'm going to start over here with this guy, 140. 140 multiplied by some prime number can also be another k, as long as it's less than 2940. Okay, well, what are my prime numbers? I'll list them over here. In particular, remember all the primes greater than 7, because we've already done the 3, the 5, the 2, 3, 5, and 7. So those primes are 11, 13, 17, 19, 23, and so on, right? All right, so I want to add on another prime here. Well, when I do that, I have to ensure that k is less than or equal to 2940. And I can do that with an 11. Just get out your calculator, and you'll see that will be less than 2940. It actually works out to 1540. So that's valid. And all I did was that I added on another prime number to my established value of k. This new k will also work because it will not change the GCD. The GCD will still end up being the same, which is a perfect square, according to the big long explanation I did earlier. Okay, let's keep this going here. How about, can I add another one? Can I add 13? That's the next prime. And if I do, I get 1820. Great, another k. Can I put in the next prime, which is 140 times 17? And that is 2380. Great, that's also less than that. And then let's see if I keep going here and add 19, that will be 2660. And then once I get up to 23, it exceeds the boundary. So these are the only ones. So 1, 2, 3, 4. I got an additional 4. All right, great. So far I have 1, 2, 3, 4, 5, and then an additional 4, which is 9. Now, if I go back and look at the answer choices, I'm still way short. So there's a lot more. Okay, so that must mean all those come from these guys here. Okay, let's start. Let's start with this guy here. 875 is k, right? So can I add on another prime number and still make it 2940, less than 2940? And the answer is no, because if I choose the smallest one, which is 11, it'll exceed 2940. So that's not going to give me any new ones. Okay, no problem. I'm done with this one. I don't need to worry about that anymore. How about 175, the next one? Can I put anything in there to make it less than 2940? I think so. How about 11? If I put 11, then that's going to work. And then I think I can also do it for 13. Yeah. Because if you take 2940 and divide by 175, it gives you about 16. So basically that means that this number has to be less than 16. And of the primes, the only primes that we have in that list that are less than 16 are 11 and 13. Okay, so I got 2 more. I got 1 here and 1 there. All right, so I'm still quite a bit short of those answer choices that are hovering around the high 20s. Because so far I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 so far. Okay, well, I'm confident that a lot of them will come from the very last part, which is this guy right here. So we're done with 175. Let's move to 35. Now we have 35. 35 times some prime number has got to be less than 2940. Okay. Well, let's call that prime number P. P's got to be less than 2940 divided by 35. Correct? And if you do that math, P's got to be less than or equal to 84. So that prime number that I put in there has to be less than 84. Well, all of these prime numbers here that I listed are less than 84. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 additional K's. And that pretty much is what brings us up to that level of the answer choices. So let's add this up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then these 19, 11 plus 19 is 30. So 30 is the answer to this excellent question, number 25. That would be choice D. Jan writes down the first n consecutive positive integers, 1, 2, 3, 4, all the way to n minus 1 and n. He removes 4 different integers, p, q, r, s, from the list. At least 3 of p, q, r, s are consecutive, and 100 is less than p, less than q, less than r, less than s. The average of the integers remaining in the list is 89.5625. The number of possible values of s is p, q, r, and s. Those are the 4 numbers. Now, they're saying that at least 3 are consecutive. Okay, so that means either 3 are consecutive or 4 are consecutive. If 4 are consecutive, this would be x, x plus 1, x plus 2, and x plus 3, right? And then the sum, which I can just denote as, I guess, s. Don't get confused with that s. I'll just call it s, large S for sum. It looks to me like 4x plus 6. That's if all 4 are consecutive. If only 3 are consecutive, then let's say that p, q, and r are consecutive, like that. And then s is some s, we don't know. The sum here looks to me like 3x plus 3 plus s. How about if the 3 consecutive were p, r, and s? So it would be x, x plus 1, and x plus 2, and this is q. Therefore, this is going to be 3x plus 3 plus q. That's sum. And then similarly, if you made the 3 consecutive p, q, and s, it would be x, x plus 1, and x plus 2, and this is r. So it would be 3x plus 3 plus r, the sum. And then finally, if the consecutives were q, r, and s, it would be like that, where this is just p. So then again, the sum would be 3x plus 3 plus p. Okay, so these are the possible ways of doing it. Now, at this point, I have to do a little bit of an approximation because they don't actually give me the value for n. They just say, okay, it's some n. So, but I have to sort of know at least ballpark estimate, where is n? Is it 105? Is it 200? 500? Right? I have to get some sort of an approximation. Okay. Well, they told me that the average of the remaining integers is that. So that's very helpful because you took n and then you subtracted 4 integers. You removed 4. So the average basically could be thought of as follows. I take n and I remove 4 and I get the average, right? Okay. But let's just say I didn't remove those 4 numbers. I just take the full average of all the numbers and let's just say it's sufficiently close to that. Therefore, I can get an approximate value of what n could be, ballpark estimate. Okay, so let's do that. I've got to first add up all my numbers all the way till n. And then to get the average, I have to divide by n. And I'm saying that that is approximately equal to 89.56, right? Okay, so what do we get here? Well, that, you know this, right? The formula for that is n times n plus 1 over 2. And then we divide by that n, and this is, the full number is 89.5625. Okay, so n times n plus 1 over 2 times 1 over n is equal to this 89.5625. It looks to me like that n cancels, so I just have n plus 1 over 2 is 89.5625. And then I can just easily sort of work this out. This looks like n plus 1 is equal to 179.125, and therefore n is equal to 178.125. So that is very helpful. It gives me some sort of an estimate as to approximately what n could be. It may be 178, 179, maybe it's 177, but somewhere around there. So n is approximately 178 and somewhere in that vicinity. Okay, so that's very helpful. So now let's move forward. Okay, let's just jump right in. let's say we take the full sum, we will subtract those four numbers, and then we figure out the average. So I'm going to start off with, well, we might as well just start off with n equals 178. I'm not sure that it's 178, but let's see what happens. So first, to get the average, we would take the sum of all the numbers, which is n times n plus 1 divided by 2. All the numbers from 1 to n. This is the sum. And then, since we're setting n equal to 178, I can just put in 178. Let's do that. So 178 times 179 over 2. And then from that, I have to subtract those four numbers. So first, let's do it for this scenario here. Okay, so I've got to subtract 4x plus 6. And then I have to divide this time, not by n, but n minus 4. Because remember, I removed four numbers. So n is 178, so I have to divide by 174. And that, they told me, is 89.5625. Okay, so let's do this math. This is 15931 minus 4x minus 6. And that gives me 15583.875. Okay. Well, that's a problem. That's a problem because when I solve all of this, I'm not going to get an integer. Because I've got this decimal here. Even if I divide through by 4, it's not going to be an integer. X has to be an integer. They told me specifically that these are all integers. Okay, so that basically means that this scenario is no good. Put a line through it. Or just put a little x beside it like that. Or just put a bracket around it. Whichever way you want to denote it. So that means I've got to use one of these four scenarios here. Okay, so let's do that. Let's talk about these though before I get into one by one. Are these possible? That's very important. This one is definitely possible according to the criteria. However, the next one, notice, is not possible because how can you do that if they're all integers? X here, x plus 1 here. Q, if it's an integer, there's nowhere for it to go. If this, for example, was 11, this would have to be 12. Q, there is no integer between 11 or 12, right? So this one is not possible. So put a bracket around there. For the same reasoning, the next one is not possible. If this was, say, 15 and then x plus 2 was 16, there's no integer that's between 15 and 16, right? So that one is not possible either. But the last one is. The last one is definitely possible. You can put some number and then you can put 3 consecutive numbers. So we are just going to go with this and try to solve the question. But before we even get into that, I've got to solve this decimal problem. I can't have a decimal if I have any hope of getting integer values. So that means that when I do this cross multiplication, this number here times this, it's got to end up to be a whole number. So you take this number and start multiplying by numbers to see what does it need to be multiplied by to give a whole number. And the smallest number that you need to multiply this by, if you do this in your calculator, is 16. 16 is the smallest number. So whatever I put here has to be some multiple of 16. And that is the, in my opinion, the key to the question. Because otherwise it takes forever. Okay, so what can that be? A multiple of 16 that is hovering around this 174 value is 176. So 176 is what I'm going to put there. So that basically means that n would be 180, right? Because what I put in here is n minus 4, remember. So now, let's try it again. Again, n is now my 180, so 180 times 181. Minus, let's just do the same scenario, 4x plus 6. Let's keep it exactly the same for comparison purposes. 89.5625. Now when I do the cross multiplication, it's great because it becomes an integer. 176 times 89.5625 as planned is an integer. It's 15763. And it gives me an integer on that side. On this side, we will have, forgot the 2 there, 16290 minus 4x minus 6. Okay, that's pretty good. So if I'm going to solve for x, bring everything over, and we're going to get 4x plus 6 is equal to, when I make that subtraction, it's 527, and therefore 4x is 521, and then x would be 130.25. Oh, that's a problem, because x represents p, and p has to be an integer. Okay, so that's no good. Well, not a problem. That just means I have to concentrate on this scenario and this scenario. Okay, so let's do that. Let's concentrate on those two, but with my n equals 180. So we have already shown that we can only deal with these two scenarios. So let's start. For the first one, it would be, since n is 180, 180 times 181 divided by 2 minus this time 3x minus 3 minus s, and then divided by n minus 4, which is 176. And that is equal to our 89.5625. Okay, so let's do this math now. This is going to be 16290 minus 3x minus 3 minus s, and that is an integer as planned, 15763. Solving for s, we get 524 is equal to 3x plus s. Okay, we can't quite yet solve for s. We have two variables. So at this point, we have to make a table. And let's make a table and see what we get. Basically, it boils down to finding integer solutions for x and s. So let's find integer solutions if we can. And then before we do, we've got to set some parameters, right? Our parameters are, let's see, well, x has got to be greater than 100, according to the question, and it's got to be less than 180, because you can't go past 180. And it looks like s probably has the same sort of criteria, at least for now. And s also has to be greater than x plus 2, because remember, these have this sort of inequality relationship. Okay, that's pretty good for now. So now let's make some numbers according to that. Well, if I start with the smallest possible, which is 101, I get 221, and that falls apart immediately because s has to be less than 180. So I keep going down, and eventually I get to 114. That gives me 182. That's still not in my range, but the very next one, 179, that falls in that range when x is 115. And then I keep going, and then eventually I get to 130 for x gives me 134. And then at that point, I start to fail this one. Everything in here, this range is fine. But then my next one, 131, gives me 131 for s. And that does not satisfy that condition. So then anything onward is not going to work. So the only ones that work are these ones right here. So 115 and so on until 130 for x, and then 179 and so on until 134 for s. And that is 16 values. Okay, so you can say, okay, great, 16, I'm done, right? Well, let's look at the answer choices. There is no 16. They're all greater than 16. Okay, so that makes me think that I've got to add a few more. So somehow I've got to come up with a few more. All right, let's see if I can. So first, let's just list all of these 16 just to have a nice comparison for us. So the 16 that we identified were from 179 all the way down to 134. So these 16. All right, so now we've done that. Now we have to do this one right here. So same story, 180 times 181. Remember, n is 180. And we're finding the sum, and then we're subtracting this time p plus 3x plus 3. Okay, and then of course we have to divide by the numbers, which is 176, and that is equal to that 89.5625. So the numbers are very similar, almost identical here. It would be minus p minus 3x minus 3, and that would be if you cross multiply the same number, which is 15763. And then that would be the same kind of story, I believe. 524 is equal to 3x plus p. So now again, let's make a table. And before we start filling out the table, let's talk about our parameters. The parameters are very similar, but the big one here is that p has to be less than x, as you can see right here. P has to be less than x. The same kind of story, that x is between 100 probably and 180, and p, same thing, at least for now. But p has to be less than x. Okay, so let's go. It's going to be pretty much the same numbers as we have over here, but this time the numbers are not for p and x and s, they're for x and p. All right, so here we go. When we start at 101 for x, right, or for p rather, you get 141. Okay, the parameters are all satisfied here, so this is legitimate. So I'm keeping that one. And then in a very similar way, let's just keep going here. 104 would give me 140, and I'm really looking for integer values. So 107 gives me 139, and so on. And you just keep making this list. So 110 would give me 138. 113 would give me 137. 116, 136. 119 would give me 135. 122, 134. 125 would give me 133. 128 give me 132, and then 131 would give me 131. Oh, okay, now this fails this inequality. So at this point I can only therefore look at these guys. Now remember, I really want s. This table has p and x, that's fine, but I want s. And what is s over here? S is x plus 2 this time, right? So s is equal to x plus 2. Okay, so now let's figure out. Let's add another column to this table, and let's put s there and see what we get. So s is x plus 2, right? Okay, so this is going to be 143, 142, 141, 140. 139, 138, 137, 136, 135, and 134. Okay, now there's some doubles here, so I can't just add what I got here to this. I got 16 over here, if you recall, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I can't just add those 10 and say, oh, it's 26, because there's some doubles here. The doubles are, let's see here. 143 is a double, so I can't count that. 140 is a double, 137 is a double, and 134 is a double. So the only new ones that I got were 1, 2, 3, 4, 5, 6. So I got 6 new ones. So I take this 16 and add to these 6 new ones, and when I do, 16 plus 6 is 22. And that is the total number of values I can get for s. And therefore, this interesting question, number 25, the answer is E.